Imagine observing a particle in a laboratory setting, one so impossibly small that it exists in multiple states simultaneously until the very moment you decide to measure it, at which point reality itself seems to reorganize and settle into a single definite state, a phenomenon that physicists have documented countless times, yet cannot fully explain within our conventional understanding of how reality should function. The particle before measurement exists in what is called a superposition, inhabiting every possible position and every possible momentum at once, a mathematical blur of probability rather than a concrete thing, yet the instant an observer or measuring device interacts with it, this infinite possibility collapses into one singular reality, one specific location, or one specific velocity. The strangeness deepens when we consider that different observers measuring the same particle in different ways will collapse the superposition into completely different states, as though consciousness or observation itself acts as a determining force in the physical universe, bending the rules of existence to match the question being asked. This mechanism operates through what we might call interpretive ambiguity, where the act of defining what we are looking for fundamentally alters what we find, creating a strange loop in which the observer and the observed become inseparably linked in ways that challenge the classical notion of an objective reality existing independently of our perception or measurement. We have built our entire modern technology upon this principle, constructing quantum computers and lasers and semiconductors that function precisely because this collapse occurs as reliably as gravity pulls downward. Yet we continue to operate within a scientific framework that accepts the phenomenon as real while simultaneously admitting that we possess no satisfactory explanation for why observation should alter physical reality at all. The persistence of this paradox, this fundamental acceptance of a mechanism we cannot truly explain, reveals how thoroughly we have normalized the borderline mystical within our understanding of science itself, treating collapse as inevitable fact rather than disturbing mystery. Perhaps this is precisely why quantum mechanics resists final interpretation, because at its core lies a question that science cannot answer through measurement alone, whether reality requires an observer to exist, or whether observation merely reveals what was always predetermined, leaving us perpetually unable to distinguish between these possibilities without the very act of looking that transforms the answer. And so we are left with a peculiar epistemic humility. The universe operates according to rules that demand our participation to become real, yet refuses to clarify whether we are authors of that reality or merely readers of a story that was always written into the fabric of existence itself. Consider the peculiar behavior of light and matter at the quantum level, where particles exhibit a strange dual nature that shifts depending on whether they are being observed or measured, a phenomenon known as the double-slit observer effect that has perplexed scientists and philosophers for over a century without reaching complete consensus on its explanation. When scientists set up an experiment with two slits and fire electrons or photons through them without any detection apparatus in place, the particles behave like waves, passing through both slits simultaneously and creating an interference pattern on a screen behind the slits, a phenomenon that suggests the particles exist in a superposition of states until observed. However, the moment researchers place a detector near one or both slits to determine which slit each particle actually passes through, the behavior changes dramatically, and the particles behave like classical objects, passing through only one slit or the other, which destroys the interference pattern entirely and creates two separate bands on the screen instead. The unsettling aspect of this experiment is that the mere act of observation, the presence of measurement apparatus, fundamentally alters the outcome of the experiment itself, as if reality itself is responsive to our attention or our technological attempts to gather information about it. The psychological mechanism underlying our acceptance of this reality error stems from our human tendency to compartmentalize phenomena that defy intuitive understanding, allowing us to accept that quantum mechanics operates under different rules than our everyday macroscopic experience without questioning what consciousness or measurement actually means in this context. We have become comfortable with the explanation that observation causes collapse of the wave function, yet the precise mechanism of how this occurs remains unclear, and physicists continue to debate whether observation requires conscious awareness, whether measurement equipment causes physical disruption, or whether the mathematics simply describes correlations without implying actual physical mechanisms. Despite decades of refinement and multiple interpretations of quantum mechanics proposed to resolve this paradox, we have normalized the double-slit observer effect as simply the way the universe works at its smallest scales, accepting it as fundamental truth rather than continuing to question why reality should behave so differently when we attempt to measure it. Yet perhaps the most profound implication is that this experiment reveals the limits of our ability to separate the observer from the observed, suggesting that at the quantum level, there may be no independent reality waiting to be discovered, but rather a participatory universe where the act of asking a question through measurement fundamentally shapes what answer nature can provide. This perspective invites us to reconsider whether the universe's behavior at quantum scales represents a fundamental truth about reality's nature, or merely reflects the inherent limitations of our current measurement tools and conceptual frameworks. Imagine thousands, sometimes millions of people, sharing the exact same false memory about something that never actually happened, a phenomenon so widespread and consistent that it defies conventional explanation of how human memory typically fails. This is the Mandela effect, named after the collective false memory that Nelson Mandela died in prison in the 1980s, when in reality he was released, became president of South Africa, and lived until 2013. Yet thousands of people distinctly remember news coverage of his death in captivity, funeral broadcasts, and mourning periods that simply do not exist in any historical record. The phenomenon extends far beyond this single instance into a vast landscape of shared false memories that span decades and affect people across different cultures, languages, and backgrounds who have no connection to one another. People remember the Berenstain Bears being spelled Berenstein, a spelling that feels intuitively correct despite the official spelling always being Berenstain. Millions recall the Monopoly man wearing a monocle, a detail that appears nowhere in any official game materials or historical documentation. Others remember the Fruit of the Loom logo containing a cornucopia behind the fruit, swearing they can visualize it with perfect clarity, though the logo has never featured this element. These memories are not vague or uncertain. They are vivid, detailed, and people defend them with absolute conviction, describing specific moments when they learned this information or saw these images with their own eyes. The psychological mechanism underlying these mass false memories likely involves a combination of source confusion, where the brain conflates similar images or information with official ones, combined with suggestibility and the power of collective reinforcement. When one person mentions remembering something a certain way, it plants a seed in another person's mind, and through repeated social exposure, the false memory becomes integrated into their own cognitive framework, feeling as real and authentic as genuine memories. The persistence of the Mandela effect, despite rational debunking efforts and clear historical evidence suggesting otherwise, reveals something unsettling about how little we can truly trust our collective memory and how easily large groups of people can develop synchronized false recollections that feel absolutely genuine from the inside. This raises the philosophical question of whether reality itself becomes unstable when enough people agree on a false version of it, or whether such phenomena merely expose the fragile nature of human consciousness and our dangerous dependency on collective validation to construct our understanding of the world. Perhaps the most disturbing implication is that if our memories can be so thoroughly compromised by social suggestion and cognitive bias, then every person's recollection of their own past, their relationships, their formative experiences, their sense of identity, exists on shakier ground than we would like to believe, leaving us all vulnerable to living in versions of history that feel completely authentic while being fundamentally unreliable. Consider the moment when you walk into a room you have never entered before, yet something about it feels impossibly familiar, as though you have lived this exact instant at some point in your past, and your mind floods with a strange certainty that you have experienced this conversation, this lighting, this arrangement of objects in precisely this configuration before, even though you know with absolute rational clarity that this is impossible and that you have never been here. This phenomenon, known as déjà vu, strikes approximately 70% of all human beings at least once during their lifetime, and for many people it occurs repeatedly throughout their existence. Yet despite more than a century of scientific investigation and countless theories proposed by neuroscientists and psychologists, the actual mechanism that produces this sensation remains fundamentally mysterious and resistant to definitive explanation. The leading theories suggest that déjà vu might result from a brief disruption in memory processing, where the brain momentarily confuses present perception with stored memories, Or perhaps it occurs when current sensory input accidentally triggers similar neural patterns to those created by genuinely past experiences, causing the temporal circuitry of consciousness to misfire in ways we cannot yet measure or predict. Some researchers propose that déjà vu represents a fleeting glitch in the brain's filing system, where an experience is simultaneously encoded as both a new memory and retrieved as an old one, creating the paradoxical sensation of novelty and familiarity occupying the exact same moment. Yet despite these reasonable hypotheses, none has been proven definitively, and no laboratory has successfully induced genuine déjà vu under controlled conditions, meaning that this common human experience continues to occur billions of times each day across the population, while remaining fundamentally unexplained by the scientific discipline that studies human consciousness. We have normalized our profound ignorance of this phenomenon so completely that most people experience déjà vu and simply move forward with their day, accepting the strangeness without question, never truly demanding an answer to why their brain would generate such a convincing illusion of temporal familiarity when no such familiarity could possibly exist. Perhaps this acceptance reflects something deeper about human consciousness itself, our willingness to coexist with mystery, to experience profound strangeness, and simply integrate it into the fabric of ordinary life, suggesting that some of the most fundamental operations of our own minds may be permanently beyond our ability to fully comprehend, no matter how sophisticated our instruments of measurement become. And yet we persist in investigating, driven by the reasonable conviction that understanding even one person's single moment of déjà vu might illuminate vast territories of consciousness we have not yet mapped, territories where the boundaries between memory and perception, past and present, known and unknown, dissolve into something far stranger than our current categories of thought can adequately describe. Consider for a moment the peculiar position in which modern neuroscience finds itself when confronted with perhaps the most fundamental question of all. Where does consciousness come from, and why does subjective experience exist at all? We can map the brain with unprecedented precision, identifying neural correlates of consciousness, measuring electrical activity across billions of synapses, observing which regions light up when a person sees color or feels pain, and yet we remain utterly unable to explain the essential mystery of why any of this activity produces the felt quality of experience itself. This is what philosophers call the hard problem of consciousness, and it represents a gap so profound that some of the greatest minds in neuroscience openly acknowledge we simply do not have a framework to address it. When you experience the redness of red or the painfulness of pain, something is happening that transcends our ability to reduce it to mere electrical signals and chemical reactions, and despite decades of advancing technology and increasing understanding of brain function, this explanatory gap has not narrowed 1 inch. The psychological mechanism underlying our acceptance of this unsolved problem involves what might be called the normalization of mystery. We have become so accustomed to the language of neuroscience that we mistake the description of brain activity for an explanation of consciousness itself, as if mapping the correlates of experience somehow addresses the deeper question of why experience exists in the first place. We tell ourselves the story that consciousness is something the brain does, the way the heart pumps blood, and yet every time we examine this claim closely, we discover it rests on an assumption rather than evidence. What makes this particularly disorienting is that consciousness is not some distant phenomenon we observe in others. It is the very foundation of our awareness, the substrate through which we know anything at all, and yet it remains among the least understood aspects of reality. We have normalized living with this contradiction by compartmentalizing our thinking, accepting practical neuroscience while quietly setting aside the philosophical problem, creating a strange intellectual peace that persists only because we rarely examine it directly and honestly. The mystery endures not because we lack the right technology or sufficient data, but because we may lack the right conceptual framework, the right questions, or perhaps even the cognitive apparatus necessary to fully understand our own nature. And yet we persist in the assumption that consciousness is merely an emergent property of sufficient neural complexity, despite having no coherent definition of what emergence actually means in this context, no threshold we can identify where subjective experience suddenly springs into being, and no explanation for why the universe should produce observers at all rather than remaining a realm of unconscious physical processes. In the late 1990s, a astronomers made an observation that fundamentally challenged our understanding of the cosmos, when they discovered that the expansion of the universe is not slowing down due to gravity as everyone had assumed, but rather accelerating at an increasingly rapid pace, pushing all galaxies away from one another with a force that seems to grow stronger as time progresses. And this acceleration cannot be explained by any matter or energy that we can actually detect or measure in any meaningful way. The observations came from studying distant supernovae, those brilliant explosions of dying stars whose light traveled billions of years to reach our telescopes. And when scientists calculated how far away these supernovae actually were compared to how fast they appeared to be moving, they found something profoundly unsettling. The universe was flying apart faster than it should be, as though some invisible hand was pushing from the outside, accelerating everything outward into an ever-expanding void. This led physicists to propose the existence of dark energy, a hypothetical form of energy that comprises roughly 70% of all matter and energy in the entire universe. Yet it remains completely undetectable to every instrument we have ever built, cannot be isolated or studied directly, and possesses properties so strange and counterintuitive that it violates many of our most fundamental assumptions about how energy and matter should behave. The psychological mechanism that allows us to accept this mystery is rooted in our willingness to trust mathematical models and observational data even when they lead us to concepts that defy explanation. And we have trained ourselves to believe in things we cannot see or touch if the equations suggest they must exist, a habit that began with gravity itself and has become the foundation of modern physics. What makes this particular mystery so profound is not just that we do not understand what dark energy is, but that despite decades of research, billions of dollars in funding, and the combined intellectual effort of thousands of physicists and cosmologists worldwide, we have made virtually no progress in determining its true nature or origin. And we have essentially normalized a state of profound ignorance by giving the unknown phenomenon a name and inserting it into our models, as though naming something is equivalent to understanding it. Yet this pattern of naming our ignorance repeats throughout cosmology. We call the mysterious matter holding galaxies together dark matter. We label the initial cosmic explosion the Big Bang, and we speak of these unknowns with such certainty in our textbooks and lectures that students often mistake nomenclature for knowledge, absorbing the comfortable illusion that mystery has been solved simply because it now has a label. Consider the documented cases where patients receiving nothing more than sugar pills or saline injections report genuine reduction in pain, accelerated healing of physical injuries, and measurable changes in their physiological markers, despite the complete absence of any active pharmaceutical ingredient in what they have consumed or received. In clinical trials across multiple decades, researchers have observed that individuals who believe they are receiving treatment for wounds, burns, surgical incisions, and chronic pain conditions demonstrate statistically significant improvements in healing rates, reduced inflammation markers, decreased infection rates, and lower requirements for actual pain medication, even when they are knowingly part of a study examining the placebo effect itself. The mechanism appears to operate through the nervous system's profound influence over immune function and tissue repair processes, whereby the expectation of healing triggers the release of endogenous opioids, reduces cortisol levels that would otherwise inhibit recovery, enhances blood flow to affected areas, and modulates the inflammatory response in ways that genuinely facilitate cellular regeneration. What remains philosophically perplexing is that these effects occur not because the patient is deceived about receiving treatment, but rather because the human brain possesses an inherent capacity to initiate real biological healing processes when primed by belief, ritual, and expectation alone. Modern medicine has largely accepted and integrated this phenomenon into clinical practice through carefully structured therapeutic contexts. Yet we have normalized something that fundamentally challenges our understanding of how consciousness interacts with physical matter and biological processes. The placebo effect persists as a borderline inexplicable bridge between thought and tissue, between expectation and measurable physiological change, suggesting that the line between psychology and biology may be far more permeable than our conventional frameworks acknowledge. If the mind can genuinely accelerate bone fracture healing or reduce surgical wound infection rates through belief alone, then perhaps consciousness itself should be reconsidered not as an epiphenomenon observing biology from a distance, but as a fundamental force actively participating in the material processes we have long assumed operate independently of our mental states. This reframing invites us to examine whether other seemingly immutable biological processes, aging, immune resilience, disease progression, might similarly respond to the generative power of expectation and belief, suggesting that our conventional separation of mind and body may represent less a truth about nature and more a limitation of our current conceptual categories. Consider the peculiar phenomenon that occurs when two particles become quantum entangled, a state in which they remain mysteriously connected across vast distances of space, responding instantaneously to measurements performed on one another, regardless of whether they are separated by meters or by light years. In laboratory settings around the world, physicists have repeatedly demonstrated that when one entangled particle is measured and its state collapses into a definite value, the other particle instantaneously assumes a corresponding state, with no detectable signal or mechanism traveling between them, no electromagnetic pulse or gravitational wave that could explain the mechanism of this connection. This phenomenon has been verified countless times through increasingly sophisticated experiments, and yet it stands as one of the deepest contradictions in modern physics, because it appears to violate the fundamental principle that nothing in the universe can travel faster than light, a cornerstone assumption upon which all of relativity rests. The mechanism behind this instantaneous connection remains utterly mysterious, and physicists have developed elaborate conceptual frameworks attempting to reconcile this behavior with our understanding of causality and locality, invoking interpretations such as the many worlds hypothesis, pilot wave theory, or non-local hidden variables, each offering a different way of thinking about what instantaneous connection might actually mean. What is particularly striking is how this phenomenon persists in scientific literature and laboratory research, not as a confirmed mechanism requiring explanation, but rather as an accepted mystery that has become normalized within the broader structure of quantum mechanics itself, a realm where particles behave according to probabilistic rules that seem to operate outside the classical constraints we observe in everyday reality. We have grown accustomed to speaking of entanglement as though it is merely one more strange facet of quantum behavior, rather than a direct challenge to our fundamental understanding of how influence propagates through space and time, and this acceptance has allowed us to continue conducting science without resolving the underlying contradiction that entangled particles appear to communicate across distances instantaneously. Something that should not be possible according to every principle of relativity we have ever tested. Yet perhaps this normalization of mystery itself deserves scrutiny. We have constructed an entire edifice of predictive power around quantum mechanics without ever resolving whether entanglement represents a genuine breakdown in our understanding of reality or merely the boundary of our current conceptual frameworks, and this distinction matters profoundly if we hope to advance beyond the mathematics that works to the physics that is actually true. We experience time as a river that flows perpetually forward, carrying us from past through present into future, and this directionality feels so fundamentally true to us that we rarely question whether it is actually a law of physics or merely a constraint of human perception and biology. Yet when we examine the actual equations that govern physical reality at the microscopic level, from Newton's laws to Einstein's relativity to quantum mechanics, we discover something peculiar. These equations are mathematically symmetrical, meaning that if we reverse the direction of time and run them backwards, they produce equally valid descriptions of physical processes. An electron moving through space follows the same mathematical rules whether time flows forward or backward. A particle collision could theoretically occur in either temporal direction without violating any fundamental law of physics. What we call the arrow of time, this seemingly absolute directionality that defines our entire existence and consciousness, appears to emerge not from the laws themselves but from entropy, from the statistical tendency of systems to move toward greater disorder. And yet entropy is itself not truly a law, but rather a probability, a likelihood that in a universe of countless particles, disorder becomes increasingly probable. We have become so accustomed to experiencing time as one-directional that we have constructed entire philosophical frameworks around it, built our memories and identities upon the assumption that the past is fixed and immutable, while the future remains open and uncertain. And we have organized our societies, our technologies, and our understanding of causation around this arrow that may not be truly fundamental. The human brain has evolved to perceive and remember events in sequence, to distinguish between cause and effect, to experience the present moment as a moving boundary between past and future. And this cognitive architecture feels so natural, so inevitable, that we project it onto the universe itself. Yet physics suggests the universe does not inherently care about this direction, that at the level of fundamental interactions, time could flow either way. And only when we zoom out to large systems of countless particles does the probabilistic arrow of entropy emerge to create the illusion of one-directional flow that structures all of human experience and makes the concept of time itself feel real. This paradox becomes even more profound when we consider that the very act of remembering, the mechanism by which we construct narratives of our lives and histories, is itself irreversible, locked into the forward arrow, so that even if the universe's laws permit time to flow backward, our consciousness appears fundamentally unable to experience or conceive of it, making the arrow of time not merely a physical phenomenon, but an inescapable property of awareness itself. And perhaps this is why the arrow of time feels so real to us, not because it exists in the equations of reality, but because consciousness itself is defined by its inability to reverse, by the one-way flow of memory and intention that makes us who we are across the span of our existence. Consider for a moment the extraordinary precision required for existence itself, where the fundamental constants of physics, the strength of gravity, the charge of the electron, the expansion rate of space, all appear calibrated to within impossibly narrow margins that would permit the emergence of stars, planets, and ultimately conscious life, a phenomenon that physicists and cosmologists refer to as fine-tuning. Where even the slightest deviation in these constants, by just a few percentage points, would render the universe fundamentally sterile and lifeless, incapable of producing galaxies or atoms or anything resembling the complexity we observe around us. The gravitational constant, for instance, cannot vary by more than 1 part in 10 to the 60th power without collapsing all matter into singularities or dispersing it so thinly that no structures could ever form. And the ratio between the strong nuclear force and electromagnetism must maintain such precise balance that the nuclei of atoms remain stable enough to exist, yet unstable enough to allow the chemical reactions necessary for biology. This observation has given rise to profound philosophical and theological speculation about whether our universe was intentionally designed by some creator intelligence, or whether we simply find ourselves in the one universe, among countless others, where these conditions happen to align through pure statistical inevitability rather than cosmic accident. Yet beneath this seemingly profound mystery lies a deeper logical peculiarity that persists despite its fundamental incoherence. The tendency to treat fine-tuning as though it were evidence of something rather than merely a description of what we observe, a conceptual sleight of hand that converts our ignorance into apparent knowledge. For we cannot meaningfully assess improbability in a universe of which we know only one example, much as a single instance of a dice roll cannot tell us whether the die was fair or loaded. The mechanism sustaining this persistent wonderment operates through our deeply ingrained pattern recognition systems, which evolved to find meaningful agency and intentionality in natural phenomena, combined with our natural reluctance to accept that existence itself might require no explanation beyond the tautological observation that we could only find ourselves in a universe compatible with our existence, a principle known as the anthropic principle. Yet this elegant logical insight somehow fails to dampen the intuitive sense that the precision itself demands explanation. Consider for a moment the simple act of seeing the color red, or tasting coffee, or feeling the warmth of sunlight on your skin, and ask yourself a question that has haunted philosophy and neuroscience for centuries. Why does this experience feel like something? Scientists can map the neural correlates of consciousness with extraordinary precision, tracking electrical impulses and chemical reactions throughout the brain, measuring wavelengths of light, and identifying receptor proteins that respond to specific stimuli. Yet none of this explains the subjective, qualitative nature of what it actually feels like to experience redness or warmth or taste. This is the hard problem of consciousness, and it represents perhaps the most profound explanatory gap in all of human inquiry. We can explain the easy problems of consciousness with remarkable success through neuroscience. We can explain how the brain processes information, how it integrates signals from different sensory systems, how it produces behavioral responses and memories, Yet the moment we ask why any of this is accompanied by subjective experience at all, we find ourselves standing at a precipice where science seems fundamentally unable to provide an answer. Every night when you close your eyes and drift toward sleep, your consciousness gradually fades, the rich tapestry of colors and sensations and thoughts beginning to dissolve, and somewhere in that transition between wakefulness and sleep lies a mystery that defies explanation. We have built our entire understanding of the physical world on the principle that everything can be reduced to matter and energy and their interactions. Yet consciousness appears to be the one phenomenon that stubbornly resists this reduction, the one thing that seems to require something beyond purely physical description. Despite having no rational explanation for why consciousness should exist at all, despite the fact that a universe of unconscious physical processes could theoretically function identically to our own, we have simply accepted this inexplicable reality as a feature of existence itself. We have normalized the most profound mystery of all by living with it every moment of our lives, by treating our subjective experiences as obvious and given rather than as the genuinely extraordinary phenomena they actually are. Yet perhaps this very normalization is itself the deepest mystery, that consciousness, rather than being solved or explained away, might be fundamentally irreducible, a brute fact of existence as basic as space, time, or the laws of physics themselves, something we must simply accept as a foundation of reality rather than derive from something deeper. If consciousness is indeed fundamental rather than derivative, then the hard problem transforms from an unsolved puzzle into a recognition that certain aspects of reality simply cannot be further decomposed, much as we cannot explain why electrons have mass or why the universe exists at all, only that these facts appear to be foundational to everything that follows. In October of 2017, astronomers detected an object moving through our solar system with characteristics so unusual that it fundamentally challenged our understanding of celestial mechanics and the origins of interstellar visitors. Named Oumuamua, which means a messenger from afar in Hawaiian, this object arrived from outside our solar system traveling at approximately 26 kilometers per second. Yet what made it truly remarkable was not its speed, but rather its inexplicable acceleration and trajectory alterations that appeared to violate the conventional laws of physics as we understand them. When scientists tracked this mysterious visitor through telescopes and calculated its path, they discovered something profoundly disturbing. The object was accelerating away from the sun in ways that could not be explained by gravitational forces alone, suggesting either an unknown propulsion mechanism or the presence of something we do not yet comprehend. The object's trajectory showed deviations that astronomers could not account for using standard models of solar dynamics, leading some researchers to propose controversial hypotheses, including the possibility that Oumuamua might be an artificial structure or spacecraft deliberately propelled by means unknown to human science, though mainstream academia has largely rejected such explanations in favor of theories involving outgassing or other natural phenomena. Yet these conventional explanations remain inadequate when examined closely, as the observed acceleration patterns do not align neatly with what outgassing alone should produce, and the object's extreme elongation and unusual reflectivity patterns add further layers of mystery to its classification. What makes this phenomenon particularly striking is how the scientific community has largely moved past the initial shock and uncertainty, normalizing Oumuamua as simply another cosmic oddity that future telescopes might eventually explain, rather than acknowledging the deeper implication that our current models of physics may be fundamentally incomplete. The object continues traveling through space beyond our reach, carrying with it evidence of processes and mechanisms that science has not yet successfully explained. Yet we have chosen to file this mystery away rather than confront what it might mean for our comprehensive understanding of the universe and our place within it. Perhaps the greatest lesson Oumuamua offers is not the answers it withholds, but rather the humbling reminder that the universe continues to present us with phenomena that exceed our current theoretical frameworks, inviting us to question whether our confidence in understanding celestial mechanics is justified or merely a comfortable illusion we have constructed to mask the vast unknowns that still surround us. Throughout history, people have reported experiencing dreams that seem to predict future events with startling accuracy, from dreams about accidents that occurred days later to visions of meetings with individuals they hadn't yet encountered, creating a profound sense that our sleeping minds possess some form of precognitive ability that transcends the ordinary limitations of human perception and time itself. These accounts are remarkably consistent across cultures and centuries, with individuals describing dreams so vivid and specific that when the predicted event actually occurs, they experience a sense of validation and wonder, convinced that their subconscious mind somehow accessed information about events that had not yet transpired in the waking world. The mechanism behind this apparent phenomenon is far more mundane than the mystical interpretation suggests, and it operates through a combination of psychological processes that our minds execute with such subtlety that we rarely notice them happening. When we dream, our brains are processing vast quantities of information accumulated from our experiences, observations, anxieties, and patterns we have unconsciously recognized in the world around us. And this processing often generates scenarios that are statistically likely to occur given the trajectories we observe in our own lives and the lives of those around us. Additionally, our memory systems are remarkably selective and prone to a well-documented cognitive bias called confirmation bias, wherein we tend to remember the dreams that came true while conveniently forgetting the thousands of dreams that never manifested, creating an illusion of accuracy that is far more impressive than the actual statistical reality. Furthermore, when a dream does seem to predict something that happens, we engage in retroactive pattern matching, finding connections and correspondences between dream imagery and real events that may be entirely coincidental. Yet our minds construct narratives of meaning that feel authentic and compelling precisely because we are motivated to believe in our own intuitive powers. The persistence of this belief, despite the absence of any scientifically validated mechanism for precognition, speaks to how deeply we desire to believe that our minds possess extraordinary capabilities, that we have access to knowledge beyond the rational and sensory, and that we are somehow connected to a greater web of causality and meaning that operates beyond the constraints of conventional physics and neurology. This yearning for transcendence through our dreams reflects a fundamental human need to feel that we possess agency and insight into our destinies, a comforting narrative that stands in sharp contrast to the humbling reality that our futures are shaped far more by probability, circumstance, and the decisions we make while awake than by the mysterious whispers of our sleeping minds. Yet paradoxically, this very human inclination to seek meaning in our dreams may itself serve an adaptive purpose, encouraging us to pay attention to our intuitions and the subtle patterns our minds detect, even if the mechanism differs vastly from genuine precognition. Consider the strange phenomenon of retrocausality, where events that occur in the present moment seem to influence decisions or outcomes that happened in the past, creating a temporal paradox that defies our conventional understanding of cause and effect. In quantum mechanics laboratories around the world, researchers have observed delayed choice experiments, where the measurement of a particle's properties in the present appears to retroactively determine how that particle behaved at earlier moments in time, as if the universe somehow permits information to travel backwards through the arrow of time itself. There are documented cases of individuals making critical life decisions moments before receiving news that would have directly prevented those decisions, suggesting an impossible coordination between past choices and future information. Some people report feeling compelled to answer phone calls an instant before the phone rings, or arriving at specific locations just as emergencies occur there, creating the eerie sensation that their present actions somehow pulled past events toward them rather than the reverse. The psychological mechanism underlying our acceptance of retrocausality involves our brain's remarkable ability to reinterpret causality after the fact, reorganizing our perception of sequential events to create narratives that feel inevitable in retrospect. When we experience these moments, our minds instinctively search for hidden connections between past and present, finding patterns and meanings that suggest some form of backward influence was operating all along. We normalize this temporal impossibility by attributing it to intuition, luck, or coincidence, thus avoiding the uncomfortable acknowledgement that cause and effect might operate in ways fundamentally opposed to everything we understand about how reality actually functions. Despite decades of scientific investigation, no consensus explanation exists for why retrocausality appears to operate at quantum scales or why human consciousness occasionally seems to participate in these backward echoes. Yet we continue living as though time flows only in one direction, as though the future cannot reach back to shape the present moment. Perhaps the most unsettling aspect of retrocausality is that we cannot definitively rule it out. Every coincidence, every uncanny premonition, every inexplicable synchronicity remains technically consistent with a universe where temporal causality flows in both directions simultaneously, leaving us to wonder whether our sense of linear time is merely a convenient illusion our minds impose upon a far more complex reality. If we accept that retrocausality might operate beneath the surface of everyday experience, we are forced to reconsider whether our choices truly originate from free will or whether they are subtle responses to future outcomes already calling backward through time. This possibility transforms every decision into a potential echo of what has yet to come, blurring the boundary between agency and destiny in ways that challenge the very foundations of personal responsibility and human autonomy. Consider for a moment the profound philosophical paradox known as the Boltzmann brain, a concept that emerges from the collision between thermodynamics and cosmology, suggesting that in an infinitely old universe experiencing endless heat-death, random quantum fluctuations could theoretically assemble the precise atomic configurations necessary to spontaneously generate a conscious mind, complete with false memories and sensory experiences, existing for only brief moments before dissolving back into entropy. This thought experiment, named after the 19th-century Austrian physicist Ludwig Boltzmann, presents a deeply unsettling reality that challenges our understanding of probability, existence, and the very nature of consciousness itself. For if we accept the mathematical framework of an infinite universe with infinite time, then the likelihood of atoms randomly organizing into a functioning brain becomes not merely possible but statistically inevitable, occurring countless times throughout eternity. The mechanism underlying this disturbing concept rests upon the fundamental laws of thermodynamics and statistical mechanics, which suggest that given sufficient time, any particular arrangement of particles, no matter how improbable, will eventually occur through random molecular motion and quantum fluctuations, meaning that the specific atomic arrangement that constitutes your brain could theoretically arise spontaneously from chaos without requiring evolutionary processes. Parental genetics, or any continuous causal chain linking you to the universe's beginning. What makes this concept particularly troubling is not merely its logical validity, but rather our collective reluctance to meaningfully engage with its implications. For we continue to construct elaborate narratives about the significance of our existence, the reliability of our memories, and the authenticity of our conscious experiences, all while quietly aware that we might ourselves be Boltzmann brains, temporary conscious configurations destined to fade into non-existence within moments. The persistence of this paradox in scientific and philosophical discourse, despite its lack of empirical verification or practical applicability, reveals something profound about human consciousness itself, suggesting that we maintain our sense of meaning and reality not because we have definitively solved these riddles, but rather because we have collectively agreed to bracket such unsettling possibilities and proceed with our lives as though such disturbing contingencies do not apply to us. Yet this deliberate ignorance serves a crucial function. Without it, the very concept of rational deliberation becomes meaningless, for if we cannot trust the continuity of our consciousness or the reliability of our reasoning processes, then our ability to contemplate Boltzmann brains themselves dissolves into absurdity, leaving us suspended between the logical necessity of accepting the possibility and the practical impossibility of living as though it were true. Consider the persistent reports throughout history of individuals claiming to have passed through solid barriers, moving from one enclosed space to another without opening doors or windows, defying every principle of physical matter we have documented and verified. These accounts emerge from credible witnesses, medical professionals, and ordinary people who describe moments of disorientation, followed by finding themselves inexplicably on the opposite side of a locked door, a concrete wall, or a sealed chamber. The phenomenon, while bearing the name of a legitimate quantum mechanical process, operates at a scale and frequency in human experience that should be entirely impossible according to established physics. Quantum tunneling occurs when subatomic particles occasionally pass through energy barriers they classically should not be able to penetrate, a behavior explained by wave function probability and quantum superposition at the microscopic level. Yet the human body, composed of trillions upon trillions of atoms, would theoretically require an astronomically improbable simultaneous tunneling event across every single particle to achieve such a feat, odds so infinitesimally small that physicists dismiss it as effectively zero. What becomes curious is how these accounts persist despite this theoretical impossibility, how they circulate through communities and institutions without being universally explained or debunked with finality. The human mind possesses remarkable capabilities for reinterpreting spatial memory, for experiencing fugue states and dissociative episodes that can distort perception of how one moved through space and time. Perhaps what we witness is not a violation of physics, but rather a profound misalignment between conscious memory and actual physical movement, a gap so complete that the individual genuinely experiences the sensation of having occupied both spaces simultaneously. The normalization of these reports suggests we have collectively accepted that the mind can negotiate reality in ways our waking consciousness cannot fully articulate or reconstruct, allowing such experiences to persist in the margins of medical literature and psychological case studies. Yet when we examine the testimonies more carefully, certain details resist psychological explanation. Individuals reporting consistent spatial landmarks they could not have known, arriving with objects they did not possess before, or multiple witnesses independently corroborating the same impossible transition, suggesting that something stranger than memory distortion may warrant serious investigation. Perhaps the most unsettling cases involve individuals who emerge in locations geographically distant from their starting point, their clothing aged or altered in ways inconsistent with normal passage of time, their bodies exhibiting physiological changes, accelerated heartbeat, altered body temperature, neural patterns showing signs of extreme stress, that suggest they have undergone something profoundly disorienting, something that conventional neuroscience has yet to adequately classify or explain. In the beginning of our universe, during those first infinitesimal fractions of a second following the Big Bang, something extraordinary and troubling occurred that physicists still cannot adequately explain, a cosmic imbalance so fundamental that it challenges our most basic understanding of reality itself. According to the laws of physics as we understand them, matter and antimatter should have been created in perfectly equal quantities, emerging from the quantum foam in mirror-image pairs that would immediately annihilate each other upon contact, releasing tremendous energy in brilliant flashes of light and leaving behind nothing but radiation. Yet here we stand, existing in a universe made entirely of matter, surrounded by stars and planets and galaxies composed of normal atoms, while antimatter exists only in trace quantities that we must laboriously create in our most advanced particle accelerators, a discrepancy so profound that our own existence should be impossible. The psychological mechanism underlying our acceptance of this mystery lies in our tendency to normalize that which we cannot explain, to compartmentalize cosmic anomalies into academic categories where they can be studied without demanding immediate resolution, allowing physicists to continue their work while the fundamental asymmetry between matter and antimatter remains one of the deepest unsolved problems in theoretical physics. We have developed various hypotheses and proposed mechanisms by which this asymmetry might have arisen, invoking complex concepts such as CP violation and leptogenesis, mathematical frameworks that allow us to feel as though we are making progress toward understanding. Yet none of these theories have been definitively proven or universally accepted by the scientific community. What persists despite decades of investigation is our willingness to accept that the universe itself operates according to principles we do not fully understand, that the very existence of consciousness and complexity and meaning emerges from a physical imbalance that remains inexplicable. And we continue to conduct experiments and refine our theories while acknowledging that antimatter asymmetry represents a gap in our knowledge that may take generations to resolve, if it can be resolved at all. Perhaps most humbling of all is the recognition that this mystery may ultimately reveal something profound about the nature of scientific inquiry itself, that some questions, born from the asymmetries woven into the fabric of reality, may require us to develop entirely new frameworks of understanding that we have not yet even imagined, suggesting that our current physics, for all its elegance and predictive power, remains an incomplete description of the cosmos. The fact that we exist at all, that atoms coalesced into molecules, that chemistry became biology, that consciousness emerged to contemplate its own origins, stands as perhaps the most profound consequence of this primordial asymmetry, a reminder that the deepest mysteries of physics are inseparable from the deepest questions of existence itself. In quantum mechanics, One of the most peculiar concepts that science has introduced into our understanding of reality is the wave function, a mathematical description that supposedly contains all possible information about a particle's state until the moment of measurement. Yet here lies the profound paradox that forms the foundation of quantum theory itself. We have never, in the entire history of physics, actually observed a wave function directly, and according to the very rules of quantum mechanics, we never will be able to. The wave function exists as a purely abstract mathematical construct, a probability cloud that describes where a particle might be found, what velocity it might possess, and what properties it might exhibit, but the instant we attempt to measure any of these properties, the wave function collapses into a single definite state, and we can no longer see the wave function itself. Scientists have built an entire framework of modern physics, including quantum computing, laser technology, and nuclear energy, upon the foundation of something that cannot be directly perceived or verified through observation. The mechanism underlying this acceptance appears rooted in instrumental pragmatism. The wave function works remarkably well as a predictive tool, allowing physicists to calculate probabilities with extraordinary accuracy, and since the predictions consistently match experimental results, the invisible abstract mathematics has been granted the status of fundamental truth. We have become comfortable with a system where the deepest nature of reality is described by equations we cannot see, collapsed by observations we cannot understand, and sustained by interpretations we cannot agree upon. Yet we have normalized this extraordinary situation to such a degree that questioning it seems almost naive. The wave function remains one of science's most powerful tools and one of its most paradoxical foundations, a ghost in the mathematical machine that runs our quantum world, demonstrating how thoroughly we have accepted the invisible as the essential building block of everything observable. Yet perhaps this acceptance reveals something deeper about the nature of scientific truth itself, that our most reliable knowledge may ultimately depend not on direct observation of reality, but rather on our ability to construct mathematical models whose predictions align with measurable outcomes, forcing us to reconsider whether real means observable or simply consistent and predictive. In this light, the wave function becomes less a description of what exists and more a description of what we can know, a distinction that fundamentally reshapes how we understand the relationship between mind, measurement, and matter itself. This shift from asking what is real to asking what can be predicted may represent not a limitation of science, but rather its most honest acknowledgement that the universe's deepest nature may ultimately transcend the categories of observation that evolved to help us survive on a human scale. Consider the peculiar phenomenon where the act of observing or measuring a physical system fundamentally alters the very nature of what is being measured, a principle so deeply embedded in quantum mechanics that physicists have stopped questioning whether it makes logical sense and instead have simply accepted it as foundational truth. When we measure the position of a subatomic particle, the particle's wave function collapses into a definite location. Yet before that measurement occurred, the particle existed in a state of superposition, occupying multiple positions simultaneously in a mathematical sense that defies ordinary comprehension. The measuring apparatus itself, the very act of directing our attention and instruments towards something, produces an unavoidable interaction that changes the system being observed, whether through photons striking an electron or through the quantum mechanics of observation itself, creating a discontinuity in the particle's behavior. This creates an almost unsettling logical paradox where reality does not seem to possess definite properties until someone or something looks at it, suggesting that objective reality might be dependent upon the presence of observation, that the universe does not fully exist in any concrete form until consciousness or measurement collapses its infinite potential states into singular actualities. Scientists have developed elaborate mathematical frameworks to describe this phenomenon with precision, creating equations and models that work flawlessly in predicting experimental outcomes. Yet they simultaneously admit that the underlying mechanism remains philosophically inexplicable and conceptually troubling. We have normalized this impossibility so completely that modern physics textbooks present it as established fact rather than as a profound mystery, teaching students to accept that measurement changes physical reality as though it were as unremarkable as gravity or magnetism, when in truth it suggests something far more disturbing about the relationship between consciousness, observation, and the fundamental nature of existence itself. The double-slit experiment stands as the clearest demonstration of this principle. Electrons behave as waves when unobserved, passing through both slits simultaneously, yet the instant we install detectors to determine which slit they actually traverse, they behave as particles and pass through only one, as if nature itself responds to our curiosity by conforming to our experimental design. This suggests that the universe operates according to a principle fundamentally different from classical physics, not as a predetermined stage upon which events unfold, but as a responsive system that generates definite properties only in response to questions posed through measurement and observation. Throughout human history and continuing into modern times, countless documented accounts describe identical twins experiencing moments of profound synchronization that seem to transcend ordinary explanation, where one twin suddenly knows something about the other twin's experience despite being physically separated by considerable distance, sometimes by thousands of miles, with no possible means of communication through conventional channels. These stories manifest in remarkably consistent patterns. A twin wakes up at the exact moment their sibling experiences an accident or injury. Another twin feels sudden, inexplicable pain in their body that matches a medical emergency their identical counterpart is simultaneously enduring. And still others report completing each other's sentences or independently making identical decisions without any prior discussion or agreement. The scientific community has largely dismissed these accounts as coincidence, confirmation bias, and the human tendency to remember striking correlations, while forgetting the countless ordinary moments when twins experience completely divergent thoughts and sensations. Yet the prevalence of these testimonies among twins themselves remains remarkably consistent across cultures, generations, and socioeconomic backgrounds. Some researchers propose that identical twins, sharing complete genetic information and often having spent 9 months in the same womb, may develop unusually attuned nonverbal communication skills through subtle environmental cues and intuitive understanding of their counterparts' patterns and behaviors, creating an illusion of telepathy rather than genuine mind-to-mind transmission. However, despite the logical frameworks that attempt to explain these phenomena through conventional psychology and learned behavior, the experiences themselves often defy such straightforward categorization, occurring instantaneously across impossible distances and involving knowledge that no amount of behavioral pattern recognition could reasonably predict. What remains genuinely perplexing is how we have collectively normalized the dismissal of these experiences while simultaneously accepting countless other mysteries of human consciousness that remain equally unexplained, treating telepathic twin connections as folklore rather than phenomena worthy of rigorous scientific investigation. Allowing the boundary between the explainable and the truly mysterious to shift, depending entirely on how comfortable we feel with the implications of what the evidence might suggest about the fundamental nature of human consciousness itself. Perhaps what we most need is not more anecdotal evidence or theoretical frameworks, but rather a fundamental shift in how we approach studying consciousness itself, one that begins by taking seriously the subjective experiences of twins themselves as valid data points worthy of investigation, rather than dismissing them as anomalies that don't fit our current understanding of neurobiology and physics. Consider the sheer mathematical improbability that defines our cosmic situation, a paradox so profound that it has occupied the minds of physicists and astronomers for decades without resolution. The observable universe contains an estimated 2 trillion galaxies, each harboring hundreds of billions of stars, and modern exoplanet surveys suggest that potentially trillions of planets exist throughout the cosmos, many orbiting within the habitable zones where liquid water and life, as we understand it, could theoretically emerge and flourish. The statistical likelihood that Earth alone hosts intelligent life capable of technological advancement appears not merely improbable but absurdly, almost offensively improbable when viewed against these incomprehensible numbers. Yet when we turn our sophisticated radio telescopes toward the heavens, when we listen intently for signals across countless frequencies, when we transmit our own messages into the void hoping for acknowledgement, we encounter nothing but silence, an overwhelming and persistent silence that seems to mock our expectations and defy our calculations. This is the Fermi paradox, named after physicist Enrico Fermi, who famously asked, simply and devastatingly, "Where is everybody?" The psychological mechanism at work here involves our human tendency to project our own existence onto the universe as a kind of cosmic norm, to assume that what happened here must have happened countless other times across the infinite stage of space and time. We construct elaborate equations, the Drake equation prominent among them, attempting to calculate the number of communicative civilizations in our galaxy alone, and these equations consistently yield results suggesting hundreds or thousands of such civilizations should exist within our Milky Way region alone. Yet the silence persists, undeniable and absolute, forcing us to confront the possibility that either our mathematical frameworks are fundamentally flawed, or that something catastrophic regularly prevents advanced civilizations from persisting long enough to broadcast their presence, or perhaps most unsettling of all, that we have misunderstood the very nature of technological advancement and what constitutes intelligence itself. What makes this paradox particularly disorienting is that we have essentially normalized our bewilderment, treating this cosmic silence as an accepted mystery rather than a screaming anomaly that should command our complete scientific and philosophical attention. And we continue our daily lives, relatively unbothered by the implications of existing alone in a universe that should statistically be crowded with voices, with technologies, with consciousness itself reaching across the light years toward us in countless forms and frequencies. Imagine that physicists have calculated the energy density of empty space, the quantum vacuum that supposedly fills the entire universe, and when they measure it experimentally, they find it to be roughly 10 to the power of 120 times smaller than their theoretical predictions suggest it should be. A discrepancy so profound and so mathematically absurd that it represents perhaps the worst prediction in the entire history of science. Yet somehow this catastrophic failure of our most fundamental understanding has become almost accepted background noise in the landscape of modern physics. The vacuum catastrophe problem emerges from a collision between quantum field theory, which predicts that empty space should roil with virtual particles constantly popping in and out of existence and contributing tremendous energy density to the universe, and general relativity, which tells us how much energy actually curves spacetime and makes the universe expand at the rate we observe. When physicists plug in the numbers from quantum mechanics, they calculate that the vacuum energy should be so monumentally large that the universe would have expanded so rapidly that no galaxies, stars, or atoms would ever have formed. Yet we exist, which means either the calculation is catastrophically wrong or there must be some unknown mechanism perfectly canceling out the energy at a precision level that strains credulity. The psychological mechanism underlying our acceptance of this problem involves what might be called theoretical resignation, a condition where scientists acknowledge a prediction failure so embarrassingly large and so fundamentally troubling that they have essentially given up trying to solve it conventionally, and instead have invented new frameworks like string theory landscape models or multiverse scenarios that sidestep rather than resolve the issue. This error of 1 followed by 120 zeros represents a gap so vast that if you were to describe it in everyday terms, it would be equivalent to predicting the weight of a single grain of sand and being off by the mass of Jupiter, a mistake so enormous that one might reasonably ask whether the entire theoretical framework producing it deserves trust at all. What makes the vacuum catastrophe particularly unsettling is that it has been known for decades, has been discussed at every major physics conference, and yet persists as an open problem without any serious consensus on its resolution, suggesting that physics has simply learned to live with a foundational contradiction of such magnitude that solving it might require overturning everything we believe about the quantum world, and so instead we have normalized the problem, written countless papers discussing its implications, and moved forward as though having the worst prediction in science is merely an interesting puzzle rather than a sign that something may be fundamentally broken in our understanding of reality. Consider the profound disconnect between measured time and experienced time that occurs during moments of intense emotional or psychological significance, a phenomenon so universal that nearly every human has encountered it, yet remains deeply difficult to explain through any standard framework of physics or neurology. When you sit in a waiting room anticipating difficult news, an hour can feel like an entire day, each minute stretching into an eternity as your consciousness seems to slow and expand in ways that have nothing to do with actual temporal mechanics. yet the clock on the wall insists that only 60 minutes have passed. Conversely, when you are deeply engaged in an activity you love, absorbed in conversation with someone meaningful, or focused on work that captivates your full attention, hours can evaporate in what feels like mere minutes, and you emerge shocked to discover that an entire afternoon has dissolved without your awareness. The strange aspect of these experiences is that they are not mere illusions or tricks of memory, because the subjective experience is genuine and measurable through your own internal sense of duration. Yet objective time has clearly remained constant regardless of your perception of it. Neuroscientists have proposed that attention, emotion, and memory encoding speed affect how our brains process temporal intervals, suggesting that when we are emotionally aroused, our internal clock ticks faster, compressing perceived duration, while when we are bored, our internal clock ticks slower, stretching perceived duration. Yet despite these attempts at explanation, the actual mechanism by which consciousness experiences time differently than physics describes, it remains fundamentally mysterious and unresolved. We have accepted this duality as simply the way human consciousness works, normalizing the gap between physical time and psychological time without ever truly explaining how or why it occurs, creating a persistent blind spot in our understanding of the relationship between mind and measurement. Perhaps this gap itself is instructive. The fact that we cannot reconcile subjective duration with objective measurement suggests that time may not be a single unified phenomenon, but rather exists in fundamentally different forms depending on whether we are observing it from outside ourselves or experiencing it from within, a distinction that physics and neuroscience have yet to adequately bridge. If we were to take seriously the possibility that subjective and objective time are genuinely different phenomena rather than merely different perspectives on the same phenomenon, it would force us to reconsider whether our most fundamental measurements of reality are actually measuring time itself, or only measuring the physical changes that occur within time, leaving the actual nature of duration as experienced from within consciousness forever inaccessible to external observation. In the laboratory of quantum mechanics, there exists a phenomenon so counterintuitive that it challenges our fundamental understanding of observation and change itself, a principle known as the quantum Zeno effect, which suggests that a watched system cannot decay or change state, as though the very act of continuous observation freezes reality into stillness. The classical example involves an unstable quantum particle that would normally decay into a different state over time, yet when scientists measure its state repeatedly at very short intervals, the particle appears to resist decay and remains frozen in its original configuration, as if the particle somehow knows it is being watched and chooses to remain stable in response to that scrutiny. This effect was named after the ancient Greek philosopher Zeno and his famous paradox about the arrow in flight, the idea being that if you could freeze time into infinitely small moments, motion itself becomes impossible. And in quantum mechanics, this becomes a literal mathematical reality rather than merely a philosophical curiosity. The mechanism behind this phenomenon stems from the wave function collapse interpretation of quantum mechanics, wherein every measurement forces the quantum system to choose a definite state from its superposition of possibilities, and when measurements occur in rapid succession, the system is continuously collapsed back to its initial state, never given the opportunity to evolve toward decay or transformation. Yet what makes this genuinely perplexing is that no one can adequately explain why observation should have this power, why the act of measurement should fundamentally prevent change, or how a quantum particle could possibly respond to being observed in such a coordinated and consistent manner, as though consciousness or awareness itself constitutes a force in the universe capable of halting entropy. We have grown so accustomed to accepting the quantum Zeno effect as simply part of how reality works at the subatomic level that we rarely pause to acknowledge how profoundly strange and unexplained this actually remains, that we have essentially normalized a phenomenon which suggests that reality itself is malleable in response to observation, a concept that sits uneasily at the border between physics and metaphysics. Perhaps most troublingly, this blurring of observer and observed suggests that the universe may not possess an independent, objective reality at all, but rather exists in a state of potentiality that crystallizes only when consciousness directs its attention toward it, raising the unsettling question of whether reality itself was waiting to be observed into existence. If such a mechanism truly governs reality at its most fundamental level, then every act of observation throughout cosmic history, from the first photons scattered by ancient stars to the light now entering our eyes, would constitute an intervention that shapes existence itself, suggesting that the universe is not merely observed, but actively constructed through the very act of being perceived. Deep within the fabric of spacetime, where gravity becomes so intense that not even light can escape, there exists a phenomenon that fundamentally challenges our understanding of how the universe preserves information. When a massive star collapses at the end of its life, it forms a black hole, a region of spacetime so densely compressed that it creates an event horizon, a boundary beyond which nothing can return. For decades, physicists believed that black holes were truly black, consuming everything that fell into them and removing that material from the observable universe entirely. However, in 1974, Stephen Hawking made a startling discovery: black holes are not entirely black. Through quantum mechanical calculations near the event horizon, he demonstrated that black holes actually emit radiation, a subtle glow of particles that causes them to slowly evaporate over vast stretches of cosmic time. This discovery introduced a profound puzzle into theoretical physics, one that has vexed the greatest minds in the field for nearly 50 years. The paradox emerges from a fundamental principle of quantum mechanics known as unitarity, which states that information cannot be destroyed in the universe. Yet if a black hole evaporates completely through Hawking radiation, all the information about the matter and energy that fell into it appears to be lost forever, violating this sacred principle. The radiation emitted seems to carry no information about what actually fell into the black hole, suggesting that the universe's past is erased, a notion that contradicts the deterministic nature of quantum mechanics itself. Physicists have proposed numerous solutions to this paradox, from the suggestion that information is somehow encoded in the subtle correlations of the radiation to the idea that the black hole leaves behind a remnant containing all the lost information. Yet none of these solutions has achieved universal acceptance. The paradox persists as one of the deepest unsolved problems at the intersection of quantum mechanics and general relativity, representing a fundamental gap in our understanding of reality. What makes this paradox so compelling is that it forces physicists to confront whether quantum mechanics and general relativity, the two pillars of modern physics, are truly compatible at the most extreme scales, or whether some deeper theory awaits discovery to reconcile their seemingly irreconcilable demands. Recent developments in string theory and quantum gravity research suggest that black holes may not be the information destroyers they once appeared to be, with some theorists proposing that information might be preserved in the intricate structure of spacetime itself or encoded in subtle correlations we have yet to fully understand. What remains certain is that resolving this paradox may ultimately reveal the deepest principles governing the universe, possibly unveiling a unified theory that finally reconciles the quantum and gravitational realms. Until that day arrives, the black hole information paradox remains a humbling reminder that the universe still guards secrets that challenge the very foundations of our scientific knowledge. Consider the fundamental nature of time itself and how it flows in only one direction through our universe, always forward, never backward, creating what physicists call the arrow of time. Yet when we examine the laws of physics at their most basic level, nearly all of them are completely reversible, meaning they function identically whether time moves forward or backward, and this creates one of the deepest paradoxes in science that remains largely unexplained. When you watch a glass fall from a table and shatter on the floor, you observe time's arrow in action because you will never see those broken pieces spontaneously reassemble and leap back onto the table. Yet the equations governing the motion of individual particles have no preference for one direction of time over another, and mathematically, a film of those particles could run in reverse and still obey the same fundamental laws. The explanation physicists offer involves entropy and the second law of thermodynamics, suggesting that the universe naturally progresses from order to disorder, from low entropy to high entropy, and this directional increase somehow creates our experience of time flowing forward. Yet this explanation merely describes the phenomenon without truly explaining why entropy increases in the first place, or why the universe began in such an extraordinarily low entropy state. The mystery deepens when you consider that entropy is itself a statistical concept based on probability rather than a fundamental law, meaning time's arrow may ultimately rest upon nothing more than mathematical likelihood, yet we experience time as an absolute, irreversible force that grants consciousness itself, allowing us to remember the past but never the future. We have built our entire understanding of causality, free will, and even the meaning of existence around this directional flow of time, never questioning whether our perception of it as absolute might be a profound cognitive bias, a way our minds organize experience rather than a fundamental property of reality itself. And despite centuries of scientific investigation, we remain unable to explain why time has an arrow at all. Perhaps the deepest irony is that our very ability to ask this question, to reflect on time's nature and construct scientific theories about it, may itself be an emergent property of time's arrow, suggesting that consciousness and the directionality of time are inseparably intertwined in ways we have yet to fully comprehend. If consciousness itself requires time's arrow to exist, then any observer capable of pondering this paradox is necessarily bound within the very asymmetry they seek to understand, trapped in a recursive loop where the tool of inquiry and the object of inquiry become one and the same, leaving us to wonder whether the arrow of time is something we discover in the universe or something we impose upon it through the mere act of observation and memory. Across thousands of documented near-death experiences reported by people from different cultures, religions, geographical locations, and time periods, a striking pattern emerges that defies conventional medical and neurological explanation. People who have clinically died and been resuscitated report remarkably similar sequences of events. The sensation of moving through a tunnel, encountering a bright light that feels warm and welcoming rather than painful, meeting deceased relatives or spiritual beings, and experiencing an overwhelming sense of peace and unconditional love that persists long after their recovery. What makes this phenomenon particularly puzzling to neuroscience is that these experiences occur during moments when brain activity should be completely absent, when consciousness itself should be impossible, and yet the accounts remain consistent not just across individuals, but across decades and centuries of human records. Medical researchers have proposed various explanations, including oxygen deprivation to the brain, the release of endorphins, or hallucinations caused by dying neurons. Yet none of these mechanisms adequately explain why the experiences would be so universally similar, or why people emerge from these events with complete personality changes, newfound spiritual convictions, and the loss of fear regarding death itself. The consistency extends beyond the basic structure of the experience into specific details that people had no way of knowing beforehand, such as accurately describing events occurring in other hospital rooms during their clinical death or encountering deceased individuals they never met in life. We have normalized this puzzle by compartmentalizing it into categories like spirituality or psychology, rather than demanding rigorous scientific investigation, allowing the profound unexplainability of near-death experiences to remain one of consciousness's deepest mysteries, one that touches the very foundation of what we understand about awareness, mortality, and the boundaries between scientific materialism and something far stranger than our current frameworks can accommodate. Perhaps most troubling is that these experiences consistently report a sense of absolute certainty and reality that survivors describe as more vivid and genuine than ordinary waking life, suggesting that whatever mechanism produces these visions operates at a level of consciousness we have yet to theoretically or scientifically access, leaving us with the uncomfortable possibility that our materialist assumptions about the nature of death and consciousness may be fundamentally incomplete. This interpretive gap, where subjective reports consistently exceed our explanatory capacity, may itself be the most important data point, suggesting that consciousness either persists beyond neural function or operates through mechanisms so fundamental that we have mistaken the map of physical brain activity for the territory of awareness itself, a confusion that may prove as historically significant as our previous misunderstandings about the nature of light, time, and reality at its deepest levels. At the quantum scale, there exists a peculiar mathematical relationship that Werner Heisenberg formulated in 1927, which states that the more precisely we measure the position of a particle, the less we can know about its momentum, and vice versa, creating what appears to be a fundamental limit to what reality itself will allow us to observe simultaneously. This principle emerges not from technological limitations or instrumental inadequacy, but rather from the very structure of quantum mechanics itself, suggesting that nature possesses an intrinsic fuzziness that cannot be overcome through improved equipment or more refined measurement techniques. When physicists conduct experiments to locate an electron with extreme precision, the act of measurement necessarily disturbs the particle's momentum in unpredictable ways, and the more forcefully they pin down its location, the more violently its velocity becomes uncertain, as though reality itself resists our attempts to extract complete information about any single quantum object. What makes this phenomenon philosophically troubling is that it represents a fundamental boundary beyond which deterministic knowledge becomes impossible, not merely difficult, suggesting that the universe operates according to probabilistic foundations rather than the classical certainties that our everyday experience suggests should govern all natural systems. The principle persists in our scientific worldview despite appearing to contradict basic logical assumptions about objective reality, namely that particles must possess definite positions and velocities whether or not we measure them. Yet experiments consistently confirm that quantum systems genuinely do not possess simultaneous definite values for these conjugate variables, indicating that the uncertainty is not epistemic but ontological, woven into existence itself rather than merely into our knowledge of existence. We have largely accepted this foundation of modern physics without fully grappling with what it means for reality to be fundamentally indeterminate at its smallest scales, and we continue to build technology and conduct science as though we understand this principle, when perhaps we have simply grown accustomed to speaking its mathematics while remaining genuinely uncertain about what it reveals concerning the nature of existence itself. Perhaps this is the deepest lesson the uncertainty principle offers, that reality at its foundation may be irreducibly relational rather than independent, with properties emerging only through the act of interaction itself, suggesting that existence and observation are not separate domains but fundamentally intertwined aspects of a single cosmic process. If this interpretation holds true, then the act of asking a question about nature fundamentally changes the answer nature can provide, transforming what we thought were passive observations into active participations in the creation of reality itself. A realization that dissolves the boundary between observer and observed, and suggests that consciousness and cosmos may be partners in an ongoing dialogue rather than separate entities locked in one-way measurement. Consider the peculiar mystery at the heart of theoretical physics. Mathematics, a purely abstract human invention created through logic and imagination, describes the physical universe with stunning, almost supernatural precision. When physicists develop mathematical frameworks in isolation, working only with equations and abstract symbols with no reference to the natural world, these same equations later prove capable of predicting phenomena in nature that had not yet been observed or even imagined. The mathematics of relativity, formulated by Einstein decades before experimental confirmation, revealed predictions about gravity, time dilation, and the curvature of spacetime that matched reality with extraordinary accuracy. Quantum mechanics, built from abstract mathematical structures, predicted the existence of particles and behaviors that experimentalists would later confirm in laboratories. String theory proposes extra dimensions and fundamental vibrations that mathematics suggests should exist, yet these exist only in the realm of equations and symbols with no direct observational evidence. The unreasonable effectiveness of mathematics to describe physical reality becomes even more perplexing when we recognize that mathematics is a human construct, born from our minds, our symbolic systems, and our logical frameworks. We created the concept of numbers, of geometric shapes, of algebraic relationships. Yet somehow, when we apply these human inventions to understand the natural world, nature responds as if it was written in the language of mathematics all along. This creates a profound dissonance in our understanding. Either the universe truly is fundamentally mathematical in nature, suggesting reality itself is abstract information, or our minds happen to resonate perfectly with the underlying structure of existence through pure coincidence. We have normalized this strangeness by treating it as simply how science works, rarely pausing to contemplate why the universe should cooperate so completely with our mathematical models. The deeper we probe into physics, the more mathematical reality becomes, yet we cannot fully explain why mathematics works at all, why the universe speaks our symbolic language, or whether we are discovering universal truths or merely projecting our own patterns onto an indifferent cosmos. Perhaps the most unsettling possibility is that mathematics is neither invented nor discovered, but rather a fundamental language that both mind and universe speak, suggesting that consciousness itself may be woven into the fabric of reality in ways we are only beginning to glimpse. If consciousness and mathematics are indeed intertwined in this way, than the act of observation itself. The moment a conscious mind measures a quantum system and forces it to choose a definite state, may not be separate from the universe's mathematical structure, but rather a fundamental aspect of how reality actualizes itself from infinite mathematical possibility. Consider the peculiar phenomenon wherein individuals across the planet report experiencing moments of profound synchronicity, where two entirely unrelated events seem to align with such precision that the probability of their occurrence together appears mathematically impossible. Yet these moments happen with unsettling regularity in the lives of ordinary people. A person thinks of an old friend they haven't considered in years, only to receive a call from that exact individual within the hour, or someone recalls a song they haven't heard in decades, and that song begins playing on the radio at that precise moment, or a person dreams about a specific sequence of events, and then witnesses those events unfold in waking life with remarkable accuracy. The scientific community has long attempted to explain these occurrences through the lens of probability and pattern recognition, suggesting that human consciousness is fundamentally wired to detect correlations and meaning in random data, a phenomenon known as apophenia, or the tendency to perceive meaningful patterns within random information. Our brains are pattern-seeking machines that evolved to identify threats and opportunities in our environment, and this same mechanism can misfire when applied to coincidental events, causing us to assign profound meaning to what is ultimately just the natural statistical distribution of events across a sufficiently large population and time frame. Yet despite having this rational explanation available to us, people continue to report these experiences with genuine wonder and conviction, and rather than dismissing them as mere cognitive bias, we have largely incorporated them into our cultural narratives about fate, destiny, and mysterious connections that bind the universe together. We have normalized the experience of cosmic coincidence to such a degree that entire industries have emerged around predicting and interpreting these moments, from astrology to tarot to numerology, each offering frameworks through which we can understand these synchronicities as meaningful communications from forces beyond our comprehension. Even though the mechanism of pattern recognition remains unchanged, and our scientific understanding has not substantially evolved to explain why these coincidences should carry significance beyond their statistical inevitability. Perhaps the true cosmic coincidence is not that these synchronicities occur, but that we have constructed an entire metaphysical infrastructure to validate our experience of them, creating a self-reinforcing cycle wherein the framework itself becomes evidence for the very phenomenon it purports to explain, leaving us forever caught between the rational dismissal of coincidence and the irresistible human need to believe that the universe is speaking directly to us. Consider the migratory patterns of birds that traverse thousands of miles across continents and oceans each year, following routes that defy conventional explanation through the mechanisms we have long assumed to govern biological navigation. These creatures possess an ability to sense the Earth's magnetic field with a precision that modern instruments struggle to replicate, detecting fluctuations in magnetism so subtle that our most sensitive equipment can barely measure them. Yet the birds navigate with an accuracy suggesting they perceive something we cannot adequately explain. The leading hypothesis, emerging from quantum biology research, suggests that specialized proteins within the bird's eyes called cryptochromes may exploit quantum entanglement and quantum tunneling effects to process magnetic information at subatomic scales, essentially allowing their biology to harness quantum mechanical phenomena in ways that classical physics cannot fully account for. These proteins appear to contain electron pairs that become quantum entangled when struck by photons, creating a state where the particles exist in multiple conditions simultaneously until observed, a phenomenon so fundamentally at odds with our understanding of how biological systems should function that scientists themselves remain uncertain whether this mechanism actually occurs, or whether birds employ some entirely different process we have yet to discover. The remarkable aspect of this situation lies not merely in the quantum effects themselves, but in how we have accepted that living organisms can apparently leverage quantum mechanics in ways that should theoretically be impossible, since quantum effects typically decohere almost instantaneously in warm, wet biological environments like those found inside animal bodies. Yet birds continue to navigate successfully year after year, suggesting either that quantum biology is far more prevalent than we realized, or that the entire foundation of our understanding requires fundamental revision. Despite decades of research and sophisticated laboratory experiments attempting to isolate and measure these quantum processes, we remain largely unable to definitively prove how birds actually accomplish this feat. Yet we have normalized this knowledge gap into academic discussions and grant applications, while the birds themselves seem entirely unconcerned with our inability to explain their extraordinary capabilities. Perhaps most humbling is the recognition that birds have been executing this navigational marvel for millions of years, refining and perfecting a biological technology that we have only recently begun to suspect exists, suggesting that nature may routinely employ quantum mechanical solutions to problems we have not yet learned to properly formulate, let alone solve through our conventional engineering approaches. For decades, scientists believed they had precisely measured one of the most fundamental properties of matter, the radius of a proton, that tiny positively charged particle at the heart of every hydrogen atom. The accepted value, derived from countless experiments and refined through generations of careful measurement, stood at approximately 0.875 femtometers, a distance so infinitesimally small that it defies ordinary human comprehension. Yet in 2010, researchers conducting experiments with muonic hydrogen, which is hydrogen where an electron has been replaced by a heavier cousin particle called a muon, discovered something deeply troubling. Their measurements suggested the proton was significantly smaller than previously thought, yielding a radius roughly 4% smaller than the established value. This discrepancy, though it might sound negligible in everyday terms, represents a profound crisis in fundamental physics because the proton is supposed to be one of the most thoroughly understood objects in existence. And if we cannot agree on its size, then something foundational about our understanding of matter and measurement itself must be questioned. The puzzle deepens when we consider that multiple independent measurement techniques using different particles and different methodologies have produced conflicting results, with some experiments supporting the traditional value and others supporting the smaller radius, creating an impossible situation where the laws of physics appear to depend on which experiment you consult. Scientists have proposed elaborate explanations involving previously unknown particles, exotic interactions between matter and energy, or fundamental flaws in our understanding of quantum electrodynamics. Yet none of these proposals have achieved consensus or satisfactorily resolved the contradiction. What makes this particularly unsettling is that the proton radius measurements touch upon some of the most basic calculations in physics, affecting how we understand hydrogen atoms, atomic energy levels, and the precise values of fundamental constants that govern all of chemistry and physics. Persistence of this puzzle despite decades of investigation by the world's most sophisticated laboratories suggests that either our experimental techniques contain systematic errors we have not yet identified, or our theoretical framework for understanding particle physics requires fundamental revision in ways we have not yet imagined, and we continue forward in an uncertain state where one of the supposedly most basic facts about matter remains genuinely, persistently contested. Recent experiments using electron-muon scattering and precision spectroscopy of muonic deuterium have only added new layers of complexity, with some results hinting that the discrepancy might not be a flaw in measurement at all, but rather a sign that we are encountering the limits of our current theoretical models and standing at the threshold of discovering physics beyond our present understanding. Among the most perplexing cases in paranormal literature stands the documented history of Edgar Cayce, a man who entered deep trance states and produced thousands of readings that allegedly predicted future events with remarkable accuracy. Statements that have fascinated researchers and believers for nearly a century, despite the complete absence of any scientific mechanism that could explain such phenomena. During his waking hours, Cayce was an ordinary photographer in Kentucky with no formal education beyond high school, yet when he lay down and entered what witnesses described as a profound sleep state, individuals would pose questions about health, business ventures, and future world events, and according to extensive records maintained by the Association for Research and Enlightenment. Many of his predictions reportedly came to pass with specific details that seemed impossible to know through conventional means. The documented cases include alleged predictions about technological advances, political upheavals, natural disasters, and medical conditions that purportedly manifested years or decades after Cayce made his statements while apparently unconscious. with supporters pointing to specific dates and circumstances that seem to align with actual historical events that occurred long after the readings were recorded. The psychological explanation for how such cases persist involves several intersecting cognitive phenomena, including confirmation bias, where people selectively remember the predictions that came true while forgetting the numerous failures and misses that constitute the vast majority of any psychic's predictions, retrofitting vague statements to match subsequent events through creative interpretation. And the human tendency to find patterns and meaning in random occurrences, because our brains are fundamentally pattern-seeking machines that evolved to detect threats and opportunities. Additionally, the passage of time and the translation of transcripts allows for subtle reinterpretation and adjustment of the original statements, while the sheer volume of predictions ensures that some will inevitably align with future events through pure statistical probability rather than any genuine prescience. Yet despite these clear psychological mechanisms being well understood and documented, the legend of the sleeping prophet persists in popular culture and continues to attract devoted followers who maintain his archives and promote his readings as evidence of human consciousness transcending the normal constraints of space and time, a phenomenon that reveals how thoroughly we have normalized the acceptance of extraordinary claims without proportional extraordinary evidence, and how readily we can maintain belief in phenomena that contradict everything we understand about neurology, physics, and the nature of human consciousness itself. Consider the moment when you think of a friend you haven't spoken to in years, and within hours that person calls you, or you unexpectedly encounter them on the street in a city of millions where such a meeting should be statistically improbable. Consider the person who decides to look up an old acquaintance online, only to discover that same person had been trying to find their contact information that very same day. Consider the individual who arrives at a bookstore searching for a specific obscure title, only to have another customer accidentally knock that exact book into their hands from a high shelf they could never have reached alone. These moments feel profound, laden with meaning, as though the universe itself has conspired to create a meaningful intersection of events that speaks directly to our lives and purposes. The Swiss psychiatrist Carl Jung termed this phenomenon synchronicity, describing it as a meaningful coincidence and a causal connection between events that share significance without one causing the other. Yet when we examine these experiences through the lens of mathematics and probability, we encounter a curious paradox that our minds seem reluctant to fully embrace. The human brain processes countless potential coincidences every single day, millions of small intersections between our thoughts, our actions, and external events that we simply do not notice or remember. But when one of these inevitable intersections aligns with something we care about or have been thinking about, our memory crystallizes around it, and we assign it profound meaning. This is the mechanism of pattern recognition combined with confirmation bias and survivorship bias, where our minds naturally filter out all the ordinary moments and retain only those rare instances that seem to defy explanation. We exist in a state of cognitive selectivity, noticing and remembering the hits while completely forgetting the misses, the thousands of times we thought of someone and they did not call, the moments we searched for something and did not find it, the days when no meaningful coincidences occurred at all. And yet, despite understanding this mechanism, despite being able to articulate the psychological explanations for why these moments feel significant, when they are actually just inevitable products of probability operating across the vast landscape of our daily experiences, we continue to experience synchronicity as something more, something that feels genuinely meaningful, and perhaps more strangely still. We have normalized this feeling to the point where encountering these coincidences seems almost ordinary, unremarkable, simply another unexplained moment we accept before moving forward with our lives. Yet perhaps this very ordinariness is itself the most synchronous moment of all, the way we have learned to hold two truths simultaneously, accepting both the mathematical inevitability of coincidence and the genuine feeling of cosmic connection, neither canceling out the other, both equally real in how they shape the texture of our lived experience. Consider the profound strangeness of what occurs in quantum mechanics when we examine the observer effect at its most fundamental level, where the act of measurement itself appears to fundamentally alter the nature of reality before the observation takes place. In laboratory settings across the world, physicists have repeatedly documented scenarios where particles exist in a state of infinite potential, suspended in what is called superposition, until the moment a conscious observer or measuring instrument directs attention toward them, at which point this infinite probability collapses into a single definite state. The particles seem to behave as though they are aware they are being watched, responding not to the physical act of measurement, but to the intention behind the observation itself, transforming from waves of possibility into concrete particles with defined properties and locations. This phenomenon has been verified through double-slit experiments, quantum entanglement studies, and delayed choice quantum eraser experiments, where the observation made in the present moment somehow influences events that occurred in the past, suggesting that reality itself is not a fixed entity, but rather a collaborative creation between the observer and the observed. Yet despite decades of rigorous scientific investigation, we have normalized this impossible scenario, accepting that consciousness or intention plays a role in collapsing the fundamental fabric of existence without truly understanding the mechanism or the philosophical implications of what this means for the nature of reality itself. We proceed as though this is simply how the universe operates, integrating this knowledge into our technologies and our understanding of physics, while simultaneously maintaining a worldview in our daily lives that treats reality as completely objective and independent of observation, creating an extraordinary cognitive dissonance that persists unexamined in the background of modern scientific thought. This contradiction becomes even more acute when we consider that the very instruments we use to make observations are themselves composed of quantum particles that require observation to achieve definite states, meaning we are caught in an infinite regress where reality collapses all the way down, each layer of measurement dependent upon the consciousness directing the previous measurement, suggesting that observation may be not merely a tool for discovering reality, but the fundamental mechanism by which reality actualizes itself from the quantum foam of pure potentiality. If this interpretation holds true, then the universe itself may be understood not as a machine operating independently of consciousness, but as a participatory reality where observation is not incidental to existence but constitutive of it, fundamentally reframing our understanding of what it means to be conscious observers within a cosmos that may, in some profound sense, require our attention in order to be. Consider the proposition that consciousness itself might arise from quantum mechanical processes occurring within the microtubules of neurons, a theory proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, which suggests that the subjective experience of awareness cannot be fully explained by classical neural computation alone. The theory posits that quantum coherence and collapse events within these cellular structures could generate the unified field of conscious experience, bridging the explanatory gap between the physical brain and the felt quality of perception that neuroscience has never adequately accounted for. In this framework, consciousness would not merely emerge from electrochemical signals passing between neurons, but would instead depend upon quantum mechanical phenomena that operate at scales far smaller than the synapses we can observe and measure with conventional neuroimaging technology. The implications are profound because they suggest that traditional neuroscience, which treats the brain as a biochemical machine operating according to classical physics, may be fundamentally incomplete in its understanding of how subjective awareness arises from physical matter. Yet when we examine the empirical evidence, no direct measurement of quantum effects in microtubules has been definitively demonstrated in living brains. No reproducible laboratory experiment has shown that consciousness requires quantum mechanics to function, and no clear mechanism has been established for how quantum processes at the atomic scale could maintain coherence long enough in the warm, wet environment of the brain to influence neural activity in meaningful ways. The theory remains largely speculative, occupying an unusual position between legitimate scientific inquiry and unfalsifiable metaphysical speculation. Yet it continues to attract serious consideration from physicists and philosophers precisely because the hard problem of consciousness remains so intractable through conventional approaches. We have somehow normalized the existence of this theoretical framework despite its lack of empirical support, allowing it to persist in academic discourse and popular imagination as though it represents a genuine scientific alternative to materialist neuroscience, when in reality it remains one of many untested hypotheses designed to address the genuine mystery of subjective experience. The appeal of the theory seems to lie partly in its intellectual prestige. that consciousness might require cutting-edge physics rather than emerge from ordinary neural processes, which may explain why it persists despite the absence of mechanisms showing how quantum decoherence could be overcome in biological systems, or why consciousness would depend on such exotic physics when simpler explanations involving integrated information processing across classical neural networks remain entirely viable. Throughout recorded history, there have been peculiar instances where groups of people, sometimes numbering in the dozens or even hundreds, have simultaneously developed identical physical symptoms with no discernible medical cause, a phenomenon known as mass psychogenic illness or epidemic hysteria. One of the most documented cases occurred in 1962 in Tanganyika, now Tanzania, where a schoolgirl began laughing uncontrollably, and within weeks, the laughter spread to nearly 100 other students and teachers, causing the school to close entirely as the contagion continued to ripple outward into the community. Similarly, in 2011, a group of teenage girls in upstate New York developed involuntary twitching and vocal outbursts that mimicked Tourette syndrome, and despite extensive medical testing revealing nothing physiologically wrong, the symptoms persisted and caused genuine distress to those afflicted. The mechanism behind such phenomena appears to involve a complex interplay of psychological suggestion, stress, and the brain's remarkable ability to generate real physical symptoms through belief and expectation alone, a process sometimes called the nocebo effect in reverse, where the mind becomes so convinced of illness that the body manifests genuine sensations of pain, weakness, nausea, or unusual movements. When one person in a group experiences symptoms, and those around them are primed by stress, anxiety, or suggestibility, others unconsciously begin to interpret their own normal bodily sensations through the lens of those initial symptoms, and their brains quite literally create the expected physiological responses, reinforcing the pattern through continued exposure and social contagion. What remains genuinely puzzling is how these outbreaks continue to occur despite modern medicine's ability to rule out physical causes, suggesting that our understanding of the mind-body connection remains incomplete, and that the power of collective belief, social dynamics, and psychological states to generate undeniable physical experiences is far greater than our current frameworks adequately explain or account for. This phenomenon raises profound questions about the nature of reality itself, whether the distinction between real physical symptoms and psychological ones is as clear as medicine traditionally assumes, and whether future research might reveal that mass psychogenic illness represents not a failure of the body or mind, but rather an extraordinary demonstration of their unified power to reshape our lived experience. Indeed, modern instances, such as the 2023 outbreak among students in Massachusetts, serve as stark reminders that even in our hyperconnected, scientifically advanced age, the invisible currents of collective anxiety and social suggestion remain powerful enough to produce waves of genuine suffering that defy conventional medical explanation. Throughout history, there have been documented cases where human bodies have allegedly caught fire and burned with intense heat without any apparent external source of ignition, a phenomenon known as spontaneous human combustion that has captured the imagination of investigators, medical professionals, and the general public for centuries. These cases typically involve victims found severely burned or reduced to ash in confined spaces where fires should not have been able to start on their own, often in homes where surrounding furniture and materials remain relatively untouched by flames despite the extreme heat required to cremate a human body. The most famous historical examples include the case of Mrs. Grace Pett in England in 1744, who was found burned beyond recognition in her home with no explanation for how the fire began, and countless other incidents documented across Europe and America in which witnesses reported seeing inexplicable flames emerging from the bodies of living individuals before they collapsed in agony. The persistence of these accounts across different cultures and time periods has led some researchers to investigate whether there exists a genuine biological mechanism within the human body that could spontaneously ignite under specific physiological conditions, perhaps involving unusual chemical accumulations or electrical phenomena within cellular structures. However, the scientific explanation for these cases reveals that what appears to be spontaneous ignition is almost always the result of the wick effect, wherein a person's clothing becomes saturated with melted fat from their own body, and when exposed to even a small external flame from a cigarette, fireplace, or stove, The fat-soaked fabric burns extremely hot and slowly, consuming the body from within while external materials nearby receive insufficient exposure to ignition temperatures. The mystery that persists despite this logical explanation is how the human mind has collectively maintained the belief in spontaneous combustion across generations, how medical examiners have sometimes failed to identify the mundane sources of ignition in their investigations, and how we continue to find something almost spiritually compelling about the idea that the human body might harbor hidden destructive forces within itself. Even in the face of straightforward physical evidence and chemical principles that fully account for every documented case. This enduring fascination may ultimately reveal more about human psychology and our need to impose mystery upon the mundane than it does about any actual biological phenomenon, serving as a reminder that even in our modern scientific age, the boundaries between rational explanation and collective myth remain permeable and contested. Throughout recorded history, observers have reported witnessing a peculiar atmospheric phenomenon known as ball lightning, a luminous sphere that appears during thunderstorms and behaves in ways that fundamentally challenge our understanding of electromagnetic theory and thermodynamics. These orbs, typically ranging from the size of a golf ball to several feet in diameter, manifest as glowing, often multicolored spheres that float through the air with apparent independence from the surrounding environment, sometimes passing through solid objects, hovering motionless in space, or moving against the direction of wind currents with deliberate purpose. Witnesses describe these formations as displaying temperatures hot enough to melt metal and leave scorch marks on structures, yet simultaneously cool enough to drift past human observers without causing severe burns, and they vanish with equally mysterious abruptness, either exploding silently or fading gradually into darkness. The fundamental problem that ball lightning presents to scientific understanding lies in the fact that no coherent mechanism adequately explains its formation, sustained existence, or behavior, as it appears to violate basic principles regarding energy conservation, electromagnetic confinement, and the behavior of ionized plasma under natural atmospheric conditions. Traditional lightning is understood as a massive electrical discharge that follows a conductive path through air, dissipating its enormous energy in microseconds, yet ball lightning persists for seconds or even minutes, maintaining its spherical shape and apparent stability without any evident power source or containing mechanism, suggesting that whatever forces govern its existence operate according to principles we have not yet discovered or recognized. The psychological mechanism that allows scientists and the general public to coexist with this phenomenon without demanding resolution stems from its rarity and the difficulty in studying it systematically. For ball lightning appears without warning, defies laboratory reproduction despite numerous experimental attempts, and leaves behind minimal physical evidence, which combines to create a convenient intellectual space where the anomaly can be acknowledged without forcing immediate confrontation with our incomplete theoretical framework. We have normalized ball lightning by classifying it as an unexplained phenomenon rather than a fundamental challenge to physics itself, thereby compartmentalizing it away from the core principles we rely upon for technology and engineering, allowing modern science to continue functioning smoothly despite harboring this glaring gap in understanding that suggests our models of atmospheric electricity, plasma dynamics, and energy behavior remain profoundly incomplete in ways we have not yet appreciated or pursued with adequate vigor. For decades, physicists observed a profound discrepancy that challenged our fundamental understanding of how the sun actually works, a gap between theoretical predictions and experimental measurements that became known as the solar neutrino problem, which emerged in the 1960s when scientists first began attempting to detect the ghostly particles that stream continuously from the sun's core in nearly incomprehensible quantities. The theoretical models of solar fusion suggested that the sun should produce a specific number of electron neutrinos based on the known nuclear reactions occurring within its interior. Yet when researchers constructed increasingly sensitive detectors buried deep underground to shield them from cosmic interference, they consistently measured only about 1/3 of the neutrinos that calculations predicted should arrive at Earth. This 30% discrepancy persisted across multiple detection methods and experiments over more than 3 decades, creating a genuine crisis in astrophysics because it implied either that our understanding of solar fusion was fundamentally wrong or that our knowledge of physics itself contained a critical flaw. The psychological mechanism behind this prolonged puzzle involved a peculiar kind of cognitive suspension where scientists maintained parallel confidence in two incompatible frameworks, accepting both that the equations were correct and that the measurements were accurate, which created an almost meditative state of uncertainty that characterized much of theoretical physics during this period. The resolution ultimately arrived through a shift in understanding particle physics rather than solar physics, when theoretical work revealed that neutrinos possess a small but non-zero mass and can oscillate between different types or flavors as they travel through space, meaning that some of the electron neutrinos produced in the Sun's core transform into muon and tau neutrinos during their journey to Earth. What remains peculiarly normalized despite this explanation is how the solar neutrino problem disappeared from public consciousness almost entirely after its resolution, with most people unaware that one of the most significant puzzles in 20th century physics had been solved, and how this solution fundamentally expanded our comprehension of particle physics, while demonstrating that the universe often operates through mechanisms far more subtle and strange than our initial observations and theories suggested possible. The discovery of neutrino oscillation not only validated the standard model of particle physics, but also opened entirely new avenues of investigation into the nature of mass itself, fundamentally altering how physicists approach questions about the universe's deepest structures and the invisible particles that permeate it. Throughout the 1970s and 80s, the United States government funded a classified program known as Stargate Project, which investigated the possibility that trained individuals could perceive distant or hidden information through means that conventional neuroscience cannot adequately explain, a practice termed remote viewing that involved placing subjects in controlled laboratory environments while asking them to describe locations, objects, or events occurring hundreds or thousands of miles away with no sensory access whatsoever. Participants would sit in isolation, often with their eyes closed, and produce detailed sketches, architectural descriptions, and behavioral observations of targets that had been sealed in envelopes or held in separate buildings, with some studies reporting accuracy rates that exceeded statistical chance by margins that peer reviewers found difficult to dismiss through conventional explanations. The Stargate program eventually concluded that while some results appeared anomalous, the effect sizes were too inconsistent, and the variables too difficult to control in standard laboratory conditions. Yet decades later, declassified documents revealed that military and intelligence agencies continued funding remote viewing research through private contractors, suggesting they believed something measurable was occurring even if mainstream science could not provide a mechanism. The psychological mechanism that allows some individuals to perform above chance in such experiments remains fundamentally mysterious, as it appears to involve neither electromagnetic sensitivity nor unconscious pattern recognition that neuroscience has catalogued, and instead seems to operate through what researchers have called anomalous cognition, a term that itself is simply an admission that the cognitive pathway involved does not fit within existing models of perception. What makes remote viewing particularly persistent as a phenomenon despite scientific skepticism is that it resists falsification in ways that conventional phenomena do not, because the absence of evidence for a mechanism does not prove the absence of the effect itself, and because enough trained practitioners report consistent, documented experiences that official dismissal has become increasingly difficult to sustain without appearing to ignore the data entirely. The fact that governments continue to investigate remote viewing through various funding channels, that private research institutes continue to run experiments with increasingly sophisticated protocols, and that some laboratory results remain in scientific literature suggests we have normalized a kind of cognitive blind spot where we simultaneously acknowledge anomalous results while refusing to integrate them into our fundamental models of how consciousness and information acquisition actually work. This cognitive dissonance between empirical observation and theoretical framework has created a peculiar epistemic situation where remote viewing exists in a liminal space, too documented to ignore, yet too anomalous to integrate, forcing us to maintain parallel explanatory systems rather than revise our understanding of consciousness itself. High in the upper atmosphere of Earth, traveling at nearly the speed of light, are particles of extraordinary energy that arrive constantly from the depths of space, striking our planet with an intensity that should theoretically be traceable to some identifiable source. Yet after more than a century of observation and study, scientists remain profoundly uncertain about where the most energetic of these cosmic rays actually originate. These particles, called ultra-high-energy cosmic rays, possess energy levels so extreme that a single particle carries as much kinetic energy as a professional baseball thrown at full velocity, compressed into something smaller than an atom. And when these rare visitors strike our atmosphere, they create cascades of secondary particles that rain down upon the surface in patterns that physicists have measured and catalogued with increasing precision. And yet the fundamental question persists unanswered in the scientific literature. The human mind seeks pattern and origin in all things, particularly in phenomena that affect us directly, even when we cannot perceive them with our senses, and when faced with a mystery as vast as the cosmos itself, we are drawn toward explanation and categorization as a way of reducing existential uncertainty. We have identified some potential sources, certainly, including remnants of supernovae and the violent regions surrounding distant galaxies. Yet when researchers trace the trajectories backward and calculate the expected distribution of these ultra-high-energy particles based on known cosmic phenomena, the numbers do not align correctly, the ratios seem slightly off, and the concentration of incoming rays from certain directions defies what our models predict should occur. What is remarkable is how seamlessly this profound gap in our understanding has been integrated into the landscape of accepted scientific ignorance, discussed in technical journals with sophisticated terminology that obscures the simple fact that we observe something regularly striking our planet while being unable to definitively explain its origin. And this reality persists in an almost dormant state within public consciousness. Neither solved nor widely recognized as the conceptual problem it truly represents, existing instead in the comfortable space where complex astrophysics meets human acceptance of mysterious natural phenomena. Yet perhaps this acceptance itself reflects a deeper truth about human knowledge, that some mysteries endure not because we lack the tools to solve them, but because the universe operates at scales and energies so far removed from our everyday existence that understanding requires us to constantly expand the boundaries of what we thought possible, and in that expansion, we discover that the origin of cosmic rays may ultimately reveal something equally profound about the limits and possibilities of scientific inquiry itself. Deep within the Amazon rainforest of Peru, the Shipibo indigenous people have practiced a form of medicine for centuries that relies on the precise recitation of Icaros, which are healing songs believed to contain specific vibrational frequencies and spiritual instructions capable of diagnosing and treating various ailments with remarkable accuracy that has confounded both anthropologists and medical researchers who have documented cases where Shipibo healers appear to identify illnesses and their root causes through song alone, without any physical examination or diagnostic equipment. Sometimes describing symptoms that patients have not yet disclosed and identifying conditions that are later confirmed by Western medical testing, a phenomenon that suggests either an extraordinarily developed system of observation and intuition or something that operates entirely outside our current scientific framework. The mechanism behind this apparent accuracy likely involves a combination of extremely refined sensory perception developed over generations of practice, an intimate understanding of human physiology transmitted orally through cultural knowledge systems that predate modern anatomy by centuries, and the deeply suggestive power of ritual and expectation, wherein a patient's own body responds to the focused intention and confident diagnosis of a healer in ways that may actually produce measurable physiological changes, while also accounting for the selective memory and confirmation bias that inevitably follows any healing practice, where patients remember the accurate predictions far more vividly than the misses. What remains genuinely puzzling is how a healing tradition that makes no claim to scientific validity has produced enough consistent results across multiple documented cases that serious researchers continue to study it rather than dismiss it outright, and how we have collectively normalized the existence of these knowledge systems as merely cultural curiosities, rather than confronting the possibility that diagnostic and healing capacities might exist that operate through pathways entirely different from the ones Western medicine has chosen to privilege, leaving us in a state of comfortable uncertainty where the accuracy of Shipibo healing songs persists as an acknowledged but unexplained phenomenon that we have learned to live with by simply choosing not to investigate too deeply. Yet when a Shipibo healer describes the exact location of a patient's tumor before any imaging has been performed, or accurately names a psychological trauma that manifests as physical pain, we are left standing at the threshold between two epistemologies, forced to acknowledge that either our instruments of measurement are inadequate to capture what is actually occurring, or that the healing itself originates from dimensions of human experience that Western science has not yet developed the language or methodology to recognize and validate. Consider the peculiar phenomenon observed in laboratories around the world where animals and humans alike seem to demonstrate knowledge or abilities they could not have acquired through conventional learning or genetic inheritance. A pattern that researcher Rupert Sheldrake has termed morphic resonance, suggesting that biological systems might access information through invisible fields that connect organisms across space and time. The theory proposes that when a sufficient number of individuals within a species learns a new behavior or skill, this knowledge becomes encoded into a kind of collective memory field that subsequent generations can tap into instinctively, without ever having been explicitly taught, as if the universe itself maintains a library of learned behaviors available to all members of that species. In the real world, this manifests as unexplained synchronicity in animal populations, where rats in separate laboratories across different continents suddenly demonstrate the ability to solve identical puzzles with increasing efficiency despite having no way to communicate, or where plants appear to respond to danger signals from other plants they have never encountered, or where humans separated by vast distances report nearly identical dreams or sudden knowledge of events they could not possibly have learned about through ordinary means. The mechanism underlying this concept challenges our fundamental understanding of how information travels and how consciousness might operate, proposing that the universe maintains interconnected fields similar to electromagnetic fields, but operating at a level we have not yet developed instruments to measure precisely, and that these fields allow for non-local communication and knowledge transfer across biological organisms. Yet despite decades of research and numerous documented cases, the scientific establishment largely dismisses morphic resonance as pseudoscience lacking sufficient empirical foundation, creating a curious cognitive dissonance where the phenomenon continues to be observed and reported across diverse cultures and disciplines, yet we persist in explaining it away through conventional mechanisms or attributing it to coincidence. As though our collective reluctance to accept such a revolutionary idea somehow prevents it from being fundamentally true. Perhaps what we are witnessing is not a failure of morphic resonance to be proven, but rather a failure of our current scientific paradigm to ask the right questions, to design experiments that would actually test for fields operating beyond our conventional measuring instruments, and to consider whether the very act of dismissing such phenomena might itself create a kind of inverse morphic field that dampens our collective willingness to investigate what our ancestors may have understood more intuitively about the interconnected nature of all living things. Stephen Hawking proposed the chronological protection conjecture in 1992 as a theoretical safeguard against the paradoxes of time travel, suggesting that the laws of physics themselves might prevent closed time-like curves from ever existing in a way that would allow information to travel backward through time and create causality violations. The conjecture was elegant in its simplicity. Nature, he argued, must somehow forbid the construction of time machines that could permit an observer to encounter their own past self or to alter events that have already occurred, because such scenarios would lead to logical contradictions that reality simply cannot tolerate. However, decades of subsequent mathematical and theoretical physics research has revealed that there is no fundamental mechanism in the equations of general relativity that actually enforces this protection, and solutions to Einstein's field equations describing traversable wormholes and other exotic spacetime geometries consistently permit closed time-like curves under various conditions without any automatic correction from the laws of physics themselves. Scientists examining rotating black holes, Alcubierre drives, and wormhole solutions find that while these structures would require exotic matter with negative energy density to construct, nothing in the fundamental physics explicitly prevents their formation or forbids the time travel paradoxes they would enable. The remarkable reality is that our universe appears to have no built-in cosmic law preventing time travel, no inherent principle that makes causality violations impossible, no physical mechanism that automatically erases or corrects contradictions before they occur. Yet we continue to operate under the comfortable assumption that time travel to the past is prohibited, that causality must be protected, that the universe enforces a kind of logical order through unknown means, even though the mathematics we most trust tells us otherwise. We have normalized the idea that something must prevent these violations without any evidence that such prevention actually exists, transforming an unanswered question into an accepted fact through the sheer force of intellectual consensus and our intuitive need for temporal safety. Perhaps this collective blindness reveals something deeper about the human condition. Our need to believe in order rather than face the possibility that the universe permits paradoxes we cannot resolve, that causality might be just another useful fiction we have constructed to navigate reality rather than a fundamental law written into the cosmos itself. If closed time-like curves exist as mathematical solutions to our most fundamental equations, then either the universe tolerates paradoxes through mechanisms we have yet to discover, perhaps through quantum decoherence, parallel timelines, or the Novikov self-consistency principle that forces events to arrange themselves harmoniously. Or we must accept that our understanding of causality itself is incomplete. That the arrow of time we experience so viscerally may be an emergent property rather than a bedrock feature of existence. In the realm of quantum mechanics, there exists a phenomenon known as quantum Darwinism, which describes how information about a quantum system becomes redundantly encoded across multiple copies within the environment. Yet the fundamental mechanism by which certain environmental states are selected over others remains deeply puzzling to physicists and philosophers alike. When a quantum system interacts with its environment, decoherence occurs, and this process has long been understood as the bridge between the quantum and classical worlds. But quantum Darwinism suggests something far more intricate and troubling is happening beneath the surface. The theory proposes that the environment acts as a selective filter, with multiple copies of the system's information being imprinted upon various environmental degrees of freedom. Yet there is no satisfactory explanation for why specific environmental pathways are chosen while others are not, as if the universe itself is making selections without any underlying rule or principle to guide those choices. What makes this phenomenon particularly disturbing is that observers can access this redundant environmental information independently, and each observer reconstructs essentially the same classical reality from their local environmental interactions. Yet we cannot explain how this coordination occurs or why the environment favors certain information redundancies over infinite possible alternatives. The psychological mechanism at work in our acceptance of this mystery is remarkably similar to how we normalize any sufficiently complex problem. We create mathematical formalisms that describe the behavior without explaining the mechanism, and we convince ourselves that the description is equivalent to understanding, when in fact we have merely reformulated our ignorance in the language of quantum mechanics. Scientists have become comfortable with the idea that the environment selects certain outcomes through a process analogous to natural selection in biology. Yet, unlike biological evolution, there is no obvious fitness function, no clear environmental pressure, and no mechanism of hereditary variation that would justify this metaphorical connection. This gap between our mathematical descriptions and our conceptual understanding has persisted for years, and we have normalized this state of affairs by publishing papers that describe quantum Darwinism's effects while treating the selection process itself as an emergent property rather than a fundamental mystery requiring explanation, allowing us to sleep soundly despite the fact that we have essentially delegated the hard problem to the word emergence without resolving anything whatsoever. There exists a persistent and intriguing phenomenon documented across numerous transplant cases, wherein recipients of donated organs report acquiring unexpected memories, preferences, personality traits, and even skills that belong to their organ donors, individuals they had never met and knew nothing about prior to surgery. These cases involve heart transplant recipients who suddenly develop an inexplicable fondness for classical music, their donors loved, kidney recipients who report cravings for specific foods the donors regularly consumed, and liver transplant patients who experience dreams containing detailed scenes from their donors' lives, complete with accurate geographical locations and family members they could not have known about through conventional means. The scientific community has largely dismissed these accounts as coincidental, as products of heightened emotional states following major surgery, or as instances of false memory construction influenced by post-operative medications and psychological suggestion. Yet the consistency and specificity of these reported experiences across independent cases and different cultures persists with an almost stubborn regularity that defies simple psychological explanation. The theoretical mechanism that some researchers have tentatively proposed involves the possibility that human cells, including those comprising donor organs, may possess an information storage capacity that extends beyond our current understanding of genetic encoding, suggesting that cellular tissue might somehow retain impressions or patterns of consciousness, emotional experience, or behavioral memory that could theoretically transfer to a new host organism through prolonged physical contact and biological integration. What remains particularly unsettling is not necessarily that these experiences occur, but rather how the medical establishment has normalized the dismissal of transplant recipients' testimonies despite their apparent consistency, creating a cultural pattern wherein patients learn to suppress or recontextualize their experiences rather than report them to physicians, resulting in an unknown volume of undocumented cases that quietly exist outside the realm of formal scientific investigation, leaving us with a phenomenon that neither medicine nor neuroscience can adequately address, yet which continues to manifest in the lived experiences of those who have undergone organ transplantation. Some researchers have begun quietly collecting these testimonies through anonymous surveys and private interviews, uncovering accounts of transplant recipients who acquired specific phobias, artistic abilities, or even knowledge of languages they had never studied, suggesting that whatever mechanism may be at work operates with a precision that mere suggestion alone cannot account for. Until the medical community develops frameworks for systematically documenting and investigating these experiences rather than pathologizing them, the question of cellular memory will remain relegated to the margins of scientific discourse, observed but unexamined, a gap between what patients know they have experienced and what institutions are willing to investigate. Throughout the past several decades, a persistent concept has circulated through scientific communities, patent offices, and the collective imagination of innovators worldwide. The notion that empty space itself contains an infinite reservoir of energy that could theoretically be tapped and extracted to power civilization indefinitely. This idea, rooted in legitimate quantum mechanical observations about vacuum fluctuations and zero-point fields, has spawned countless experiments, prototypes, and claims of breakthrough technologies that promise to revolutionize human energy production by harnessing this supposedly boundless resource. Yet despite numerous attempts by researchers, entrepreneurs, and independent inventors to demonstrate a working zero-point energy device that produces more energy than it consumes, no such device has ever been successfully replicated under controlled scientific conditions or brought to practical application at any meaningful scale. The psychological mechanism driving belief in zero-point energy appears to stem from a combination of factors: the genuine complexity of quantum mechanics, which renders it difficult for most people to fully comprehend, the appeal of a solution that would elegantly solve our energy crisis without requiring behavioral change or sacrifice, a deep human desire to find hidden knowledge or technology that has been suppressed or overlooked by mainstream science, and the seductive narrative of the lone inventor or underdog researcher challenging established dogma. What makes zero-point energy particularly persistent as a modern mythology is that it exists in a liminal space between legitimate physics and unfounded speculation, allowing proponents to point to real quantum phenomena while simultaneously claiming that the implications of those phenomena are being deliberately ignored or misunderstood by the scientific establishment. The concept has become normalized in popular culture, appearing regularly in science fiction, alternative energy discussions, and patent applications, to the point where many people accept its theoretical existence as settled fact even as the fundamental barrier to extracting such energy remains precisely where it has always been in the laws of thermodynamics themselves, which prohibit the creation of a machine that violates conservation of energy regardless of how infinite the theoretical source might be. The persistence of zero-point energy belief also reveals something profound about how modern humans navigate uncertainty. When the frontier of physics becomes too abstract to visualize, and when our energy problems feel genuinely urgent, the possibility of a hidden solution becomes psychologically irresistible, even as the mathematical and experimental evidence continues to demonstrate that no such shortcut exists. The dream of zero-point energy thus persists not because the physics has changed, but because the human need for a painless solution to intractable problems remains constant, making it a modern mythology that will likely endure as long as we face energy scarcity and the temptation to believe that revolutionary answers lie just beyond the edge of accepted science. In the realm of quantum mechanics, there exists a profound paradox that challenges our fundamental understanding of reality itself, one that emerges from the mathematical framework known as Bell's theorem, which was formulated in 1964 by physicist John Stuart Bell as a response to debates about the completeness of quantum mechanics and the nature of hidden variables. Bell's theorem establishes that no local hidden variable theory can reproduce all the predictions of quantum mechanics, meaning that if quantum mechanics is correct in its predictions, then either the universe is fundamentally non-local, allowing instantaneous influence across arbitrary distances, or reality itself does not possess definite properties independent of observation. When experiments test Bell inequalities, they consistently reveal that quantum systems violate these mathematical bounds in ways that classical physics cannot accommodate, suggesting that particles separated by vast distances can instantaneously influence one another in a manner that appears to defy the principle of locality, which has been a cornerstone of physics since Einstein's theory of relativity established that no information or influence can travel faster than light. The mechanism underlying this violation involves quantum entanglement, wherein two particles become correlated in such a way that measuring a property of one particle instantaneously determines the corresponding property of the other, regardless of the distance separating them. Yet this phenomenon does not permit faster-than-light communication because the results of measurements appear random until compared, creating a peculiar situation where correlation exists without causality in the traditional sense. Despite decades of experimental confirmation showing violations of Bell inequalities in countless laboratory settings, with increasingly sophisticated tests closing loopholes and refining measurements, the implications of locality violation remain philosophically unsettling and scientifically unresolved, as physicists continue to grapple with questions about whether this represents genuine non-locality, a fundamental property of reality that we must simply accept, or whether some deeper theoretical framework might eventually reconcile these observations with our intuitions about locality and separability. The persistence of this paradox reflects how modern science has normalized accepting phenomena that contradict our everyday experience and classical intuition, acknowledging that the quantum realm operates according to principles so alien to macroscopic reality that complete understanding may require abandoning assumptions about the nature of space, time, and causality that have guided human thought for centuries. Some physicists propose that many worlds interpretations or relational quantum mechanics might preserve locality in modified forms, while others embrace the non-local nature as fundamental, suggesting that entanglement reveals a hidden interconnectedness woven into the fabric of existence that transcends our conventional notions of separation and independence. Consider the experience of noticing the time 11:11 on a digital clock, and then seeing those same numbers appear again 3 days later, followed by encountering them in an address, a receipt total, and a page number all within the span of a single week. This phenomenon has become remarkably common in the lives of countless individuals who report seeing repeating sequences like 333, 444, or 1212 throughout their daily existence, often at moments that feel coincidentally aligned with their thoughts or concerns. The pattern extends beyond simple number repetition to include birth dates that match phone numbers, addresses that contain significant years, or license plates that mirror meaningful dates, creating an uncanny sense that the universe itself is communicating through numerical synchronicity. What makes this experience so compelling is not merely the observation itself, but the profound sense of meaning that attaches to it, the feeling that these numbers are trying to tell us something, that they represent cosmic breadcrumbs or divine messages specifically intended for our consciousness. The psychological mechanism underlying this phenomenon is elegantly simple yet profoundly powerful, operating through selective attention and confirmation bias, where our brains become exquisitely tuned to notice matching patterns while filtering out the vastly greater number of times we see different numbers and different combinations that we never record or remember. Once we become aware of a particular pattern, our pattern recognition systems, which evolved over millions of years to detect predators and opportunities in the natural world, begin scanning our environment with heightened sensitivity, making that pattern appear everywhere. We forget the countless occasions when we checked the clock and saw random numbers, but we vividly remember the 3 times we saw 1111, cementing the illusion of cosmic frequency. The phenomenon persists in modern consciousness despite our logical understanding of probability and selection bias, because the experience of noticing these patterns feels immediate and real in a way that abstract statistical knowledge does not, and because finding meaning in apparent randomness remains one of our deepest psychological needs. This hunger for meaning is particularly acute during times of uncertainty or transition, when we are most vulnerable to seeking reassurance, making the appearance of a meaningful number feel like validation from a benevolent force, rather than a natural consequence of how human attention and memory work together to construct narrative from noise. Yet ironically, the very act of seeking these patterns can become self-fulfilling. The more we look for meaningful numbers, the more our brain obligingly manufactures connections, transforming what began as a curious observation into a kind of benevolent conspiracy theory in which we become the center of a numerically encoded universe designed entirely for our benefit and enlightenment. Deep within the chloroplasts of plant cells exists a process that operates with an efficiency that defies conventional understanding, a phenomenon that has quietly puzzled physicists and biologists for decades, and yet we have largely accepted it without fully comprehending its mechanisms. When plants convert sunlight into chemical energy through photosynthesis, they achieve energy transfer efficiency rates that hover between 90 and nearly 100% in certain conditions, which is remarkable when compared to the best solar panels humanity has engineered, which typically max out around 20% efficiency under ideal laboratory circumstances. What makes this discrepancy so profoundly strange is that the quantum mechanics involved suggest this level of performance should be impossible according to our classical understanding of how energy moves through biological systems. The light harvesting complexes in photosynthetic organisms contain pigment molecules arranged in precise geometries, and these molecules should theoretically experience decoherence almost instantaneously when exposed to the warm, wet environment of living cells, a state of quantum collapse that would render quantum phenomena ineffective almost immediately. Yet somehow, experimental evidence reveals that energy absorbed by these pigment molecules travels through multiple pathways simultaneously, exploiting quantum superposition to explore every possible route to the reaction center before settling on the most efficient path, as if the system possesses a form of quantum sensing that allows it to sample reality before committing to a single classical outcome. This behavior suggests that photosynthetic organisms have evolved the ability to maintain quantum coherence in their light harvesting machinery despite all the thermal noise and molecular vibration that should obliterate such delicate quantum states, a capability that seems almost impossibly sophisticated for life to have discovered through random evolutionary processes alone. The mechanism by which plants accomplish this feat remains deeply mysterious, with some researchers proposing that the warm environment itself, rather than being detrimental to quantum effects, might actually be essential to maintaining the vibrational scaffolding that keeps quantum pathways accessible and functional. We have essentially normalized this impossible achievement, incorporating it into our expanding understanding of quantum biology, without pausing to truly confront the implications of the fact that living systems appear to routinely accomplish quantum computing feats that our most advanced laboratories can barely maintain for microseconds, suggesting either that we fundamentally misunderstand the nature of quantum decoherence in biological contexts, or that evolution has discovered technological principles we have not yet learned to recognize or replicate in our engineered systems. In the realm of theoretical physics, there exists a concept that seems to violate everything we understand about entropy and the conservation of energy, yet it continues to exist in scientific literature and laboratory experiments as a genuine phenomenon that defies classical explanation. Time crystals represent a state of matter where atoms arrange themselves in a pattern that repeats not just in space, as ordinary crystals do, but also in time, creating a perpetual oscillation that appears to maintain itself without any external energy input, a discovery that emerged from the work of physicist Frank Wilczek in 2012 and has since been experimentally verified in multiple laboratories across the world. The mechanism operates through what scientists call discrete time translation symmetry breaking, a quantum mechanical process where particles continue to oscillate between states in a regular, repeating temporal pattern even at their ground state, which should theoretically be impossible because reaching the lowest energy state means ceasing all motion entirely. What makes time crystals particularly unsettling to our understanding is that they seem to exhibit a form of perpetual motion that occurs not despite the laws of thermodynamics but somehow within them, existing in a space where conventional logic suggests nothing of the sort should be possible. Yet the evidence accumulates steadily in peer-reviewed journals and increasingly sophisticated experiments. We have normalized this impossibility by wrapping it in quantum mechanical language and mathematical formalism, transforming something fundamentally paradoxical into merely another exotic state of matter that requires an advanced degree to comprehend fully, which allows us to acknowledge its existence while maintaining psychological comfort through technical obscurity. The deeper discomfort lies in recognizing that there exists a class of physical phenomena that appear to contradict our most fundamental intuitions about energy and time, and rather than questioning whether our intuitions need revision or whether something profound is being overlooked, we have simply filed it away as one more strange quantum curiosity awaiting future understanding. Yet perhaps this is precisely the pattern, that nature continues to reveal phenomena at the edges of our comprehension, forcing us to expand our frameworks rather than dismiss what we cannot immediately explain. And time crystals may represent not a violation of physical law, but an invitation to recognize that our understanding of perpetual motion itself has been too narrow, too bound by classical assumptions about what entropy truly permits. The experiments themselves, from Google's quantum processors demonstrating time crystal signatures to cold atom systems maintaining oscillations across thousands of cycles, suggest that perpetual motion may have always existed in nature, waiting only for our instruments to become sensitive enough to perceive it, challenging the very assumption that entropy's arrow moves only forward and never permits even the smallest corners of reality to escape its dominion. Consider the remarkable phenomenon observed in certain organisms, particularly planarian flatworms and some species of salamanders, where severed body parts not only regenerate but appear to do so with perfect anatomical accuracy, as though some invisible blueprint guides the regrowth of tissues, organs, and neural pathways with astonishing precision. Researchers working within the field of bioelectricity have discovered that these organisms possess measurable electrical fields that organize and coordinate cellular activity. And more perplexingly, when these creatures are injured, their bioelectric signatures appear to shift and reorganize before any visible physical regrowth begins, suggesting that electrical information precedes and directs biological reconstruction in ways that conventional genetic explanations alone cannot fully account for. The mystery deepens when scientists observe that by artificially manipulating these bioelectric fields using specific ion channel blockers, they can dramatically alter how tissues regenerate, causing tadpoles to develop eyes in impossible locations or creating xenobots, living computer-designed organisms that assemble themselves according to parameters that defy traditional developmental biology. The mechanism at work appears to involve what researchers term bioelectric memory or anatomical homeostasis, wherein the organism maintains an electrical template of its intended form, and when that form is disrupted through injury, the bioelectric field essentially recruits nearby cells to restore the pattern. Yet this explanation raises profound questions about where this template is stored, how it persists independently of genetic instruction, and whether consciousness or some form of cellular intention might be involved in this process. Despite decades of investigation, mainstream biology has largely compartmentalized bioelectric phenomena into specialized subdisciplines, treating electrical activity as secondary to genetic control, rather than exploring the possibility that bioelectricity might represent a fundamental information system that orchestrates life itself, allowing the reality of regeneration to persist as a genuine mystery that science documents without truly comprehending. A phenomenon we have learned to accept and file away rather than confront with the intellectual humility it demands. Yet perhaps the deepest mystery lies not in understanding how bioelectric fields guide regeneration, but in recognizing that this phenomenon suggests living systems possess a form of biological cognition or decision-making capacity that operates entirely outside our current framework of molecular biology, challenging us to reconsider whether the very distinction between life and consciousness might be far more permeable than our scientific categories allow. Consider the moment when a physicist observes an isolated quantum system that should theoretically remain in a pure state, existing in superposition across multiple possible configurations. Yet somehow through the process of measurement and interaction, this system appears to collapse into thermal equilibrium as though it had been in contact with a heat bath all along, defying the reversible nature of quantum mechanics that we understand from first principles. The eigenstate thermalization hypothesis proposes that individual energy eigenstates of a complex quantum system can behave like thermal states, meaning that when you measure certain properties of these eigenstates, you obtain values that match what you would expect from classical thermodynamic equilibrium, even though the system itself has undergone no actual dissipation or interaction with an external environment. This creates a profound paradox. How can a closed, isolated quantum system that obeys perfectly reversible equations of motion somehow produce irreversible thermodynamic behavior from within its own structure, suggesting that thermalization emerges not from external noise or loss of information, but rather from the intricate entanglement and complexity of the system's own internal correlations. The psychological mechanism that allows us to accept this phenomenon without demanding immediate resolution stems from our compartmentalization of quantum mechanics and thermodynamics into separate domains of applicability, where we have grown accustomed to treating them as valid in their respective realms without insisting they cohere into a unified framework that explains both scales simultaneously. We have normalized the existence of this deep conceptual gap by accepting that quantum systems at very small scales behave one way, thermodynamic systems at everyday scales behave another way, and the bridge between them remains obscure, allowing the eigenstate thermalization hypothesis to persist as a description of mathematical patterns rather than as a true explanation of nature's foundational mechanisms. Yet when we examine specific systems, a collection of interacting particles in a box, a chain of quantum spins with nearest neighbor coupling, we find that ETH successfully predicts which observables thermalize and which do not, suggesting that beneath our conceptual discomfort lies a genuine structural truth about how complexity itself generates the appearance of irreversibility from reversible foundations. The discovery that many-body localization can prevent thermalization in certain disordered systems demonstrates that ETH is not universal, but rather depends on the system's ability to spread information across its degrees of freedom, implying that thermalization itself is a property of connectivity rather than an inevitable consequence of quantum mechanics. This distinction between systems that thermalize and those that remain localized opens a new question: whether the arrow of time itself emerges not from fundamental laws but from the statistical structure of how information can flow through a given system's architecture. There exists a peculiar phenomenon within human physiology that defies conventional thermodynamic explanation: the ability of the human body to maintain stable core temperature despite operating through what could be described as quantum coherent states at the cellular level. When we examine the mitochondrial function that generates cellular energy through oxidative phosphorylation, we find that electrons tunnel through barriers in ways that classical physics suggests should not occur. Yet these quantum tunneling events happen continuously and contribute measurably to metabolic heat production. The body maintains a core temperature of approximately 37 degrees Celsius through a combination of metabolic processes, yet the precision with which this temperature is maintained across different individuals and environmental conditions suggests an underlying coherence mechanism that goes beyond simple biochemical regulation. Some researchers have observed that individuals who practice certain meditative states report experiencing simultaneous sensations of both intense internal heat and external cold, yet their actual core temperature readings remain stable, indicating that perception and physiological reality may be operating through different quantum channels. The hypothalamus serves as the body's thermostat, yet it receives signals from peripheral temperature sensors that should theoretically create feedback loops prone to oscillation and instability, yet instead the system maintains remarkable equilibrium. When we consider that quantum coherence in biological systems is generally thought to be disrupted by the warm, wet environment of the body. The persistence of coherent energy transfer in electron transport chains becomes increasingly difficult to explain through conventional models alone. We have normalized this explanation by simply attributing everything to classical biochemistry, yet the precision and efficiency of these processes suggest something more fundamental operating beneath the surface of our understanding, something that maintains biological order through mechanisms we have yet to properly categorize or measure. Perhaps the most intriguing aspect of this phenomenon is that the body's thermal stability may itself be the visible manifestation of quantum coherence maintaining order at the macroscopic scale, where biological systems have evolved to harness quantum effects not despite the classical world, but precisely because quantum coherence provides the thermodynamic precision that survival demands. This coherence-based thermal precision may explain why certain physiological anomalies, such as the ability of some individuals to survive extreme hypothermia or maintain consciousness during rapid temperature fluctuations, seem to involve an adaptive quantum reorganization of cellular processes rather than merely passive resistance to thermal stress. Consider the gravitational constant, that fundamental numerical value denoted by the letter G, which governs the strength of gravity itself throughout the entire universe. And notice how this single number appears to be calibrated with such extraordinary precision that even the slightest variation in either direction would render the universe fundamentally incompatible with the existence of stars, planets, and ultimately life itself. The gravitational constant is approximately 6.674 times 10 to the negative 11th power in standard units, and this specific value determines how strongly mass attracts other mass across the cosmos, meaning that if this number were larger by even 1 part in 10 to the 60th power, stars would burn out so rapidly that complex chemistry and biological evolution would have no opportunity to unfold, while if this constant were even fractionally smaller, gravity would be too weak to ever pull clouds of gas together into the stellar furnaces necessary for nucleosynthesis and the creation of heavier elements. What makes this fine-tuning so conceptually troubling is that the gravitational constant appears to have no deeper explanation rooted in more fundamental physics, no obvious reason why it must possess exactly this value rather than any other value across a landscape of mathematical possibilities. Yet here we find ourselves in a universe where the dial is turned to precisely the setting required for our own existence to be possible. The psychological mechanism that allows us to coexist with this mystery involves a subtle form of circular reasoning in which we normalize the improbable by simply noting that we could not observe a universe configured differently, since we would not be present to do the observing, a logic that satisfies our rational minds even as it leaves the deeper question of why these conditions occurred at all completely unresolved and mysterious. We have developed sophisticated theoretical frameworks that treat the gravitational constant as a given initial condition rather than something requiring explanation. And through this normalization, we have managed to build an entire scientific worldview without confronting the genuine strangeness of the fact that the universe appears tailored to our specifications. A reality that persists at the foundation of modern physics, despite decades of theoretical advancement, and despite the profound logical discomfort such precision should inspire when we truly allow ourselves to contemplate it without the comfortable abstractions of mathematics shielding us from its implications. Yet when we examine the multiverse hypothesis, the speculative framework proposing countless universes with varying physical constants, we find ourselves merely postponing the ultimate question rather than answering it, for we must still account for why our particular universe emerged from whatever metaphysical process governs the generation of multiverses in the first place, leaving us trapped in an infinite regress of explanation that suggests the mystery of fine-tuning may be fundamentally irreducible to scientific methodology. Consider the simple act of combining hydrogen and oxygen atoms through chemical bonding, a process that seems straightforward enough in its molecular mechanics, yet produces water, a substance with properties that cannot be predicted or explained by examining hydrogen and oxygen in isolation, properties like liquidity at room temperature, the ability to dissolve countless compounds, its unusual expansion when freezing, and its capacity to sustain life itself. This phenomenon of emergence, where combinations of elements create entirely new characteristics that the individual components do not possess and cannot logically account for, appears throughout nature in ways that challenge our fundamental understanding of how reality should function, from consciousness arising mysteriously from neural activity in the brain to flocking behavior in birds that seems coordinated without a conductor, to the social structures of ant colonies that accomplish complex engineering without central planning, each example representing a jarring gap between what we know about the parts and what we observe in the whole. The psychological mechanism that allows us to accept emergence involves what might be called compartmentalization, where we maintain separate mental models for different scales of organization, never quite forcing ourselves to confront the logical contradiction that properties can exist at one level of analysis without existing at another, that a system can possess capabilities its constituents seemingly lack. That assembly itself might be generative in ways our reductionist science cannot accommodate. We have normalized this mystery so thoroughly that we rarely pause to consider how remarkable it truly is, how our most sophisticated physics and chemistry cannot actually explain why a pile of atoms arranged one way produces sweetness while arranged another way produces bitterness, or why consciousness feels like something when neurons firing seems like it should feel like nothing at all, and instead we simply layer new terminology over the gap. Calling it emergence or complexity or systems behavior, words that describe the phenomenon without actually explaining the mechanism, creating an illusion of understanding while the fundamental mystery persists undisturbed beneath our language and our academic papers. Allowing us to drift toward sleep with the comfortable notion that science has answers when truly we have only learned to organize our ignorance into increasingly sophisticated frameworks that maintain the appearance of explanation. While the universe continues to generate properties, experiences, and phenomena that remain fundamentally inexplicable within the very scientific worldview we have constructed to explain them. Consider the notion that empty space is not truly empty, but rather teeming with quantum fluctuations and virtual particles that constantly wink in and out of existence according to the uncertainty principle, a fundamental law of quantum mechanics that suggests reality at the smallest scales is inherently uncertain and probabilistic in nature. The Casimir effect, first predicted by Dutch physicist Hendrik Casimir in 1948 and subsequently demonstrated experimentally, reveals that when two uncharged metallic plates are placed extraordinarily close together in a vacuum, separated by mere nanometers, a measurable attractive force emerges between them that pushes them together with genuine physical power. This force arises not from any conventional source of energy or interaction, but rather from the quantum vacuum itself, where virtual particles and antiparticles spontaneously appear and annihilate one another in the infinitesimal spaces between the plates. And because the plates physically restrict which wavelengths of quantum fluctuations can exist in the narrow gap between them, fewer virtual particles can manifest in that confined space compared to the space outside the plates, creating a pressure differential that pushes inward with measurable force. The psychological mechanism underlying our difficulty comprehending this phenomenon stems from our intuitive understanding that a vacuum is absolute nothingness, a complete absence, and yet this effect demonstrates empirically that nothingness itself possesses properties, exerts influence, and contains latent energy waiting to manifest under specific conditions, challenging our fundamental assumptions about the nature of empty space and the boundary between existence and non-existence. We have normalized this impossible reality by integrating it into quantum field theory and accepting it as merely one more counterintuitive but mathematically consistent prediction of our modern understanding of physics. Yet the Casimir effect persists as a profound mystery because despite decades of experimental confirmation and theoretical modeling, the deeper mechanism remains obscured, leaving us uncertain whether this is truly a property of fundamental reality or whether our equations are capturing something far more subtle about the structure of spacetime itself that we have yet to fully comprehend. What makes the Casimir effect particularly unsettling is that it suggests the vacuum is not a passive backdrop to physical phenomena, but an active participant in the cosmos, potentially explaining dark energy and the accelerating expansion of the universe itself, phenomena that continue to dominate cosmological research without complete understanding. If the quantum vacuum possesses such demonstrable power in laboratory conditions, we are compelled to reconsider whether the largest structures in existence might ultimately be shaped by the same mysterious forces we observe at the smallest scales. Consider the fundamental problem that has occupied molecular biologists for decades. A protein molecule, composed of long chains of amino acids, must fold itself into an extraordinarily specific three-dimensional structure in order to function properly, and this folding process must happen with breathtaking speed. The mathematical reality of this situation becomes almost incomprehensible when examined closely, because the number of possible configurations that a protein chain could theoretically adopt is astronomically large, approaching numbers so vast that even attempting to enumerate them becomes meaningless. A relatively small protein containing just 100 amino acids could theoretically fold into approximately 10 to the power of 100 different ways, which exceeds the total number of atoms in the observable universe. And yet a protein of this size accomplishes its correct folding in mere microseconds, sometimes even faster. This temporal window is so impossibly narrow compared to the theoretical search space that it defies conventional understanding of how molecular systems should operate according to standard thermodynamic principles and random molecular motion. The mechanism that allows this to occur appears to involve some form of hierarchical folding pathway, where the protein explores certain configurations preferentially rather than randomly sampling the entire possibility space. Yet the origin of this mysterious guidance system remains poorly understood and largely mysterious. The protein seems to know, somehow, which direction to fold, which configurations to avoid, and which pathways lead toward the correct final structure. And this knowledge is somehow encoded within the chemical properties of the amino acids themselves. Yet we struggle to explain precisely how such information translates into such rapid and accurate molecular choreography. What makes this phenomenon particularly perplexing is how completely we have normalized this seemingly impossible feat, how it is treated as an ordinary background fact of biochemistry rather than recognized as something that fundamentally challenges our understanding of molecular kinetics and probability. We observe these proteins folding with impossible efficiency day after day within every living cell, and we accept it as simply how nature works, rarely pausing to contemplate that we are witnessing something that should not be possible according to the mathematical constraints we understand. Yet when we attempt to artificially guide protein folding in laboratories, employing supercomputers and sophisticated algorithms, we still struggle to match the speed and accuracy that an unguided protein achieves spontaneously in a cellular environment, suggesting that the solution to this paradox may lie in dimensions of molecular behavior we have yet to properly recognize or measure. In the quantum eraser experiment, physicists have observed what appears to be a phenomenon where the present moment can retroactively influence information about the past, creating a logical loop that challenges our understanding of causality and temporal sequence. The experiment begins with photons being fired through a double-slit apparatus, and when detectors are placed to determine which slit each photon passes through, the particles behave as expected particles do, creating two distinct bands on a screen behind the apparatus. However, when scientists remove the detectors or erase the which path information through a process called quantum erasing, the photons retroactively seem to have traveled through both slits simultaneously, as if they knew in advance that their past would be erased, and therefore adjusted their behavior accordingly before that erasure even occurred. This creates a profound conceptual paradox where the future choice to erase information appears to determine the past behavior of particles that had already presumably made their quantum decisions. The mechanism appears rooted in the wave function and superposition, where particles exist in multiple states until measured, and the act of measurement or erasure can collapse or uncollapse these states in ways that seem to reach backward through time. What makes this particularly unsettling is that physicists have confirmed this effect repeatedly in laboratories worldwide, yet cannot fully explain why information about future erasure would influence past quantum behavior or how causality permits effects to precede their causes. We have normalized this phenomenon by carefully framing it within mathematical probability and quantum field theory, allowing it to become accepted scientific fact despite remaining fundamentally mysterious and deeply counterintuitive to human experience and reasoning. Yet perhaps this mystery points to a deeper truth, that our conventional notions of past and future may be less fundamental than the quantum mechanical relationships that bind them together. suggesting that time itself might be a construct we impose upon a reality where causality operates according to principles entirely foreign to our intuitive sense of sequential cause and effect. If we accept this possibility, then the universe itself might be fundamentally non-local and atemporal, where all events exist in a vast quantum web of correlations rather than a simple linear progression. And consciousness or observation merely selects which classical narrative thread we experience as reality and history. In this framework, the quantum eraser becomes not merely a laboratory curiosity, but a window into the participatory nature of reality itself, where the universe does not exist in any definite state independent of the web of potential observations that could be made of it, and where the past remains genuinely open until the present moment crystallizes one particular history from the infinite branching possibilities that quantum mechanics suggests are equally real. Firewalking is a practice documented across numerous cultures and historical periods, wherein individuals walk barefoot across beds of burning coals, hot sand, or flames without sustaining severe burns or blisters. And this phenomenon has persisted for centuries despite our inability to fully explain the physiological mechanisms that protect the human body from what should be catastrophic thermal damage. The practice typically involves preparing a bed of coals by burning wood until it reaches temperatures exceeding 1,000 degrees Fahrenheit, creating a surface that would theoretically cause instantaneous tissue destruction upon contact with human skin. Yet practitioners report minimal to no pain during the experience and exhibit remarkably little visible injury afterward, leaving scientists and medical professionals with an incomplete understanding of how the body achieves this protection. The conventional explanations offered by physics and physiology suggest that the brief contact time between skin and coals, the low thermal conductivity of the ash layer that forms on the coal surface, and the body's own moisture creating a temporary insulating barrier might account for some degree of protection. Yet these mechanisms do not adequately explain why individuals can walk slowly and deliberately across these surfaces. Nor do they account for the historical records of individuals performing extended firewalking without any apparent preparation or physical conditioning. The psychological component appears equally significant, as practitioners often report entering trance-like states or deep meditative conditions before firewalking, and those who approach the coals with fear or doubt tend to experience burns, while those who maintain absolute confidence and mental focus do not, suggesting that consciousness itself plays a role in the body's thermal protection that modern neuroscience has not yet successfully mapped or understood. The practice has been adopted by motivational speakers and corporate team-building programs in contemporary Western culture, where thousands of participants each year walk across hot coals, most emerging unscathed, yet the scientific community remains deeply divided on whether the phenomenon represents an undiscovered physiological mechanism, a psychological-induced altered state that genuinely protects tissue, or a combination of factors we have simply failed to measure correctly. What makes firewalking particularly difficult to explain is that it defies our linear understanding of cause and effect, where intense heat should inevitably produce injury regardless of mental state or preparation, yet the consistency with which prepared individuals succeed contradicts this expectation. And we continue to witness this reality without having developed a coherent framework that encompasses both the physical and mental dimensions of the experience. Consider the experience of an individual who has lost a limb, perhaps through amputation due to accident or disease, yet continues to feel that limb as though it still exists in three-dimensional space, complete with sensation, movement, and sometimes even pain that ranges from mild tingling to excruciating burning that no amount of medication or physical intervention seems capable of fully relieving. This phenomenon, known as phantom limb sensation, affects the majority of amputees within the first 24 hours following their surgery, and remarkably, it persists for years or even decades in many cases, despite the absolute certainty that the limb no longer exists and cannot possibly be generating any sensory information whatsoever. The person experiencing this sensation knows with complete intellectual clarity that their arm or leg is gone, they have seen the stump, they have adapted to its absence in their daily life, yet their brain continues to insist with remarkable persistence that the limb remains attached and functional, sending signals that feel utterly authentic and impossible to dismiss through sheer will or rational thought alone. The mechanism underlying this phenomenon appears to relate to the brain's construction of what neuroscientists call a body schema, an internal neural map of the body's physical boundaries and spatial orientation that becomes deeply embedded in the cerebral cortex and does not simply erase itself when the physical reality changes. The brain has spent decades developing this map through constant sensory input and motor experience. And even after amputation, the neural pathways and synaptic connections that comprise this map remain largely intact, continuing to fire and create the subjective experience of a limb that no longer sends any actual signals from the periphery. What emerges is a contradiction between knowledge and sensation, between what the conscious mind understands to be true and what the sensory systems and deeper brain structures insist is occurring. And this contradiction persists with a stubbornness that defies simple explanation or resolution through conscious effort or even through years of adaptation and acceptance of the amputation itself. The phantom limb sensation thus represents a peculiar failure of the body and brain to synchronize, a lag in the updating of fundamental neural architecture that persists despite overwhelming evidence that it should have adjusted long ago. Yet despite this neurological inflexibility, the persistence of phantom sensation also reveals something profound about the brain's remarkable commitment to preserving the architecture of selfhood, suggesting that what feels like a malfunction may instead represent the mind's stubborn refusal to abandon the neural patterns that have defined embodied existence, even in the face of irreversible physical change. Consider the case of individuals who, following a traumatic brain injury or the onset of dementia, suddenly develop extraordinary abilities in mathematics, art, music, or calendar calculation that were entirely absent throughout their entire previous lives. Abilities that emerge not through years of practice and dedication, but rather overnight, as though some dormant capacity within the brain has been violently awakened by damage rather than cultivation. These accounts represent one of the most perplexing phenomena in neurology and psychology, challenging our fundamental understanding of how the brain develops skills and how consciousness relates to hidden potential. In documented cases, individuals with no prior musical training have begun composing elaborate symphonies after suffering strokes, while others with no mathematical background have gained the ability to perform complex calculations instantaneously, or artists without previous artistic inclination have produced sophisticated drawings and paintings with remarkable technical precision. The conventional explanation suggests that brain damage or disease in certain regions might somehow disinhibit other areas, allowing latent abilities to surface, or that the brain's neuroplasticity enables rapid reorganization of neural pathways to compensate for damaged regions. Yet this explanation remains fundamentally incomplete and unsatisfying, because it fails to account for where these specific skills originate in the first place if they were never learned or developed. How can the brain suddenly possess technical knowledge it never acquired, mathematical understanding it never studied, or artistic skill it never practiced? And why would damage to one area suddenly grant access to abilities that require years of training and internalization to develop normally? We have largely accepted this paradox into our scientific framework without adequate resolution, categorizing it as a known phenomenon while leaving the core mechanism obscure. And we continue documenting cases of sudden savant emergence as though repetition of the observation somehow clarifies the underlying impossibility, all while patients themselves often report feeling as though these abilities were somehow always present within them, waiting beneath the surface, suggesting dimensions of human consciousness and neural organization that remain fundamentally beyond our current explanatory capacity. Perhaps most unsettling is that these emergent savants sometimes possess knowledge of techniques or artistic movements they have never encountered, demonstrating fluency in specialized domains that should remain inaccessible without formal exposure and study, as though consciousness itself contains archives of human achievement that exist independent of individual experience. This suggests that what we term brain damage may not be creating abilities so much as removing the neural filters that ordinarily prevent access to a vast, shared repository of human knowledge and capability that dwells beneath the threshold of normal awareness. At the smallest scales of reality, below the Planck length of approximately 1.6 times 10 to the negative 35 meters, spacetime itself is theorized to cease being smooth and continuous, instead transforming into a roiling, turbulent sea of quantum fluctuations known as quantum foam, where virtual particle pairs constantly materialize and annihilate in a ceaseless dance of creation and destruction that operates according to principles we can barely formulate, let alone verify through direct observation. This concept emerges from the marriage of quantum mechanics and general relativity, two pillars of modern physics that describe the behavior of the infinitesimally small and the cosmically large. Yet when we attempt to reconcile them at the quantum scale of gravity itself, we discover that spacetime develops an almost foam-like texture where the very fabric of existence becomes uncertain and indeterminate, fluctuating in ways that our current mathematical frameworks struggle to contain or explain with any degree of confidence. The psychological mechanism underlying our acceptance of quantum foam stems from the profound gap between human sensory experience and the actual structure of reality at scales we cannot perceive, combined with our tendency to extrapolate from working theories into domains where those theories may no longer apply, creating a narrative comfort in imagining spacetime as something comprehensible, even when the evidence suggests it operates in fundamentally inaccessible ways that defy classical intuition. What makes quantum foam particularly difficult to reconcile with our understanding is that we have virtually no experimental evidence for its existence, no direct observational confirmation, and no clear methodology for detecting effects that would prove or disprove its reality. Yet physicists continue to treat it as a legitimate theoretical construct worthy of serious mathematical attention and research investment. We have normalized this peculiar situation where we accept as real a phenomenon that exists purely in theoretical mathematical models, that cannot be measured or observed directly, and that operates at scales smaller than any instrument could ever hope to access, representing perhaps the ultimate expression of physics relying on pure mathematics and logical consistency rather than empirical verification. A departure from the scientific method's traditional emphasis on observation that remains largely unremarked upon in popular discourse about the nature of reality itself. Yet this theoretical acceptance reflects a deeper pattern in modern physics. We have become comfortable building elaborate mathematical architectures on foundations we cannot empirically test, trusting in the internal consistency of our equations and the predictive power of our models, even when direct observation remains forever beyond our reach. A pragmatic but philosophically troubling compromise between the demands of rigorous science and the genuine mysteries that lie at reality's deepest levels. Consider the peculiar nature of reality at its smallest scales, where physicists have discovered that the universe itself appears to possess a fundamental granularity, a kind of cosmic pixelation that emerges at distances smaller than the Planck length, approximately 1.6 times 10 to the negative 35 meters, a scale so impossibly minute that it exists far beyond our ability to observe or measure directly. Yet the mathematics of quantum mechanics and general relativity both seem to suggest that below this threshold, spacetime itself ceases to be continuous and instead becomes quantized, broken into discrete units like pixels on an ancient computer screen. And this discovery fundamentally challenges our intuitive understanding of reality as a smooth, infinitely divisible continuum. The human mind has evolved to perceive the world at macroscopic scales where objects appear continuous and solid, where space flows smoothly in all directions, where time ticks forward in an unbroken stream. Yet the deeper we probe into the nature of existence through mathematical formalism and experimental inference, the more evidence accumulates suggesting that this continuity is merely an illusion created by the coarseness of our perceptual apparatus, and that at the Planck scale. Reality itself becomes discrete, quantized, almost computational in nature. What renders this phenomenon so psychologically disorienting is that we cannot directly test it, cannot create instruments sensitive enough to observe this pixelation, and therefore must rely entirely on theoretical frameworks that push our concepts of space and time to their breaking points, creating a strange disconnect between what we mathematically predict should exist and what our instruments can ever hope to confirm, leaving us in a peculiar epistemic position where we accept the pixelation of reality as likely true based on mathematical consistency rather than empirical verification. Despite the profound implications of this discovery, despite the fact that it suggests reality itself has a granular structure fundamentally incompatible with our everyday intuitions, we have largely normalized this revelation into academic discourse, compartmentalized it within theoretical physics, and continued living our lives as though spacetime remains perfectly smooth and continuous, as though the universe operates at all scales with the same principles, when in fact we may be living within a computational substrate more alien and fundamentally discrete than we dare to fully comprehend. Yet perhaps this very inability to perceive the pixelation is itself a feature rather than a bug, a merciful limitation that allows consciousness to emerge and persist within a quantized cosmos. For a mind capable of perceiving reality at the Planck scale might find itself paralyzed by the vertigo of that revelation, trapped in an infinite regress of discrete units where meaning itself dissolves into mathematical abstraction.